Hello, everyone, and welcome to Hackout 2023. And we are so glad that you could join us here. Thank you very much for joining the session where we get to hear from some fantastic, talented speakers. But before we get into them, I wanted to say a big hello and a big welcome. My name is Kynan Francis, and I am joining you all the way from Berlin. I'm part of the Headout team, and Headout is the ones who have put together this fourth edition of Hackout. If you haven't heard of Headout before, let me tell you a little bit about Headout. Headout is the home to the world's best real-life experiences. So essentially, we are a travel company, but we offer our customers a selection of the best experiences the world has to offer at affordable prices while encouraging spontaneous travel. We want people to get out, head out, and experience the world that they live in. And so, a little bit more about us. We think that travel is a fundamental need. We want people to get out there every day, and we also want to make sure that that people get out to experience the world that they live in. And so we use technology, obviously, to do that. We have our platform. We have our that we connect our users with the experiences in the world, and so obviously, hacking is something, and hackouts are something that we are really, hackathons are something we're really interested in. And so we're happy to sponsor our own one again this year in 2023. So we're very excited for this year's Hackout because we have this year over 12,000 applications. So a big, big thank you to all of you who have joined us this year and who are jumping in on this call right now. This year, so the Hackout, we aim to bridge the gap between the student community and the real world, and to give fresh minds the perfect platform to bring your unique ideas to life. So not only will you get today to immerse yourself in some great speaker sessions, but you also get the chance to win big. Think about Headout credits, your opportunity to go out and use the Headout yourself, some cool merchandise, and exclusive giveaways, and plenty more. Plus, is up for grabs some internships and potential PPOs as well. Now, I want to say that we are streaming this live across YouTube and Twitter and potentially across some other neighboring platforms as well. I want to have a big shout out to all of our viewers who are currently watching us on YouTube and Twitter. But also, we have some support from a couple of universities this year. And I want to mention some of the campuses that are supporting us here. We have IIT Madras, IIT Kharagpur, the Delhi Technical University, and also IIT Allahabad, which I believe are actually here streaming with us today. So I'm hoping that we may be able to flick across to them and get a big hello and a big shout out to the IIT Allahabad team. But maybe we'll be able to do that a little bit later on. There's a little bit of an audio video delay, so we'll be able to try and catch up with them later on, perhaps. But someone will be able to give me a head up if we can connect with them later on. Before we jump into the speakers, I also want to talk about a little bit more about some of the prizes that we have up for grabs at Hackout this year. The winning team will receive 1.2 lakh Indian rupee, and the first runners-up will get 70,000 Indian rupee, as well as the second runners-up of 50,000 Indian rupee. Now, of course, the ideas, as you know from the brief, we accept all kinds of technical technical solutions and hack solutions, but we do have a special prize if it's something to do specifically with travel, because yes, indeed, we are a travel industry. We are the travel industry, travel company, and so we have a special travel tech award as well for 30 Indian rupees. Also, best design, and the top 10 teams will get some awesome Headout swag bags. So I just want to then also mention that if you have any questions along the way, that we have our website at hackout.io for more details about what's going on and the schedule. But let's not dwell too long on intros. I want to make sure that we make some time for all of our speakers today. We have some great speakers lined up. Our first speaker today on the schedule is Vikram Jitsing. And Vikram, I know fairly well because he's actually part of the founders here at Headout, one of the three founders. And he'll be presenting our opening session for Hackout speakers this year. We have three founders here at Hackout. So the interesting thing is that the other two, Varun and Suren, met each other at a hackathon themselves. So that's but for something a little bit more specific about Vikram that I want to share with you is that he is a very, very talented coder, but also he's actually excellent at playing the guitar and singing. So I don't know if he's got that part played as part of his presentation today, but maybe he'll surprise us. All right, then. So actually, before we jump in, like Vikram, are we able to get a connection now with IIT Allahabad? Do we have the connection set up now? Wonderful. Hey. There we are.
Yeah.
Hi, Vikram. How are you doing?
I'm well. How are you?
Very good. I'm so glad that you can kick us off for the speaker sessions today at Hackout 2023. And do we have any volume down the other end, Vikram, for IIT Allahabad?
They are unmuted.
We can see you. Can I get a big old wave from everyone who's streaming in from IIT Allahabad? Can we see you there? There we go. Okay, a few hits. Yay! So good to see you. Thank you very much for joining us. Big shout out to everyone who's joining on campus at IIT Allahabad. Yeah. Beautiful. We got some volume too. Very nice. Very nice indeed. Good. Well, thank you very much for joining us. I'm happy to have you here, and also to everyone, all your students who are joining other campuses that listened out before. But without any further ado, I want to pass across to Vikram, who's going to kick us off for the afternoon.
All right. Thank you for that. Let me just first of all, thank you everyone for coming up, whomsoever is watching the stream right as of now. This is the fourth edition of Hackout that we are doing, and this time we are doing Hackout in a hybrid fashion across 4 different colleges, and having a lot of participation coming online from various different colleges across India. So yeah, thank you for taking out the time and joining up, and hope you have a really good hackathon. And yeah, I'm very sure we're gonna have some fun, talking together. So let's start together. Let's start off with the sessions. Let me just quickly share my screen. Can you see my screen? I think you can, right? So I'm gonna just I'm gonna just make this full screen. Just give me 1 second. All right, can one of the hosts just quickly come up and tell if they can see the full screen and even my mouse? Hosts? Yes, no hosts?
Sorry, yeah, you can, Vikram.
All right, cool. Thank you for that. Cool. So let's start off with the presentation. Yeah. So basically, good, right? Cool. Headout is, so this whole session is basically about you getting to know about Headout and the engineering product culture over here. So who are we? So Headout is basically a platform for people to discover the eclectic things to do in this world, which we believe are very innate to human nature, and that like everyone yearns to go out and experience the world out there. And we create a platform and a marketplace where we connect all the consumers with all the supply out there through our unique distribution channels. So, at a glance, Headout is basically a platform that enables discovery of eclectic experiences, experiences that can be booked on demand. So, it's not just a place that you go ahead and read content. You can actually go ahead and transact on these experiences, book these experiences on the get go. So you can basically just land up in New York City, find different things to do, like go for a Statue of Liberty tour, or a Broadway musical, a walking tour of Central Park, hop on, hop off buses, and you can book them on the fly. You get them at very incredible and competitive prices that you won't find elsewhere, and it's a completely seamless booking experience. So, where are we right as of now? Well, we are live in 132 cities right as of now. And obviously, like, this map doesn't encompass or doesn't show each and every city's name. But some of the major cities are listed over here, but we are live in 132 cities right as of now. And let's get some numbers to set the record straight. Since the beginning of time, we have actually gone ahead and served 21 million guests. I mean, if you have to take a vanity metric of how much is that number compared to some population of countries, then you will probably get like the largest 60th country's population will be around this number. So 25 million plus users who have been served. Overall, till now in lifetime, we have done around $790 million worth of GMV. GMV is basically sales. We have customers from 190 plus countries, and we currently have 12,000 plus active experiences on the platform. So, how does our growth look like? This is our growth chart, and I just wanted to be very public and very upfront about how how our some of our metrics look like. So, if you see our chart, like, these are our quarters over here, and these are the revenue numbers. If you see, like, when we started off, this might seem like a small thing, but these are still in, like, single digit millions. And like all throughout before COVID, like, Headout was basically expanding and growing very fast, and in a very good trajectory. But in between, like, COVID happened, and everyone basically knows, like, COVID was basically like a sort of a travel industry killer. But I think that's, like, if I look back at it, like, that's a proud moment for me, because like, the team over here basically held the ground and built for long term. And if you see, like, our post COVID, like, the sales went to zero, but after that there has been a resurgence of the sales. And, like, at this point, we actually became like a profitable company. And that was in the midst of COVID. And right as of now, we have basically smashed our pre-COVID numbers, and are much higher than what we were at in pre-COVID times. So if you look at it, we are like we are on the trajectory of doing more than $100 million in sales just this quarter, which is an amazing thing. So, in a gist, we're a company with a global audience. We're a very lean company. We like to, we don't like to throw bodies at problem statements. We like to throw quality at problem statements. We are currently CM2 profitable. We have led travel recovery post COVID, which was very obvious via the previous chart. And we are even currently growing exponentially. So how do our funding numbers look like? Like, well, we've done around 50 plus million in funding with our last funding, which was our Series B, which happened in 2022. And like this is like a vague representation of what are the cities that we are trying to expand towards by end of next year. So you can expect us to be there in like 250 cities around the world by next year end. Cool. So, where are our offices? So, we are headquartered in Bangalore. The majority of our team is in Bangalore, and we have like a really cool space over here. And we have back offices in Berlin, London, Barcelona, Rome, New York, etc. And then there's another office which is your home, because we are open for remote working. Now that is something that depends upon team to team also how they arrange that, but that's something that we are pretty proud of, and we think like that a hybrid working mechanism is like a really good working mechanism out there. So let's talk about engineering at Headout. um, this is like a graph which basically just sort of tries to encompass what all different kinds of technologies we are using, and like there are various different technologies that we are using out there. So let's talk about the backend and infra. uh, so backend and infra has a lot of technologies. I'll talk about this later also, but like we are very language and framework agnostic company or engineering team. We don't limit ourselves to a particular stack, and we like to use different things depending upon their own use cases, rather than just defining that, hey, let's just stick to this and that's what we'll do. So you'll find a lot of things like Java, Kotlin, Spring, Python, Django, Vertex, JS, Go. We have a microservices architecture. I think we might be having like around 20, 30 microservices right as of now running. And we have public distribution APIs that distribution partners can tap into. We have third-party API plugin abstractions, which is basically an abstracted layer whereby over which we can build plugins that connect to different systems out there, which are systems that our supply partners uses. We have Dockerized containers and Kubernetes orchestration, on-demand environments, which are enabled via Kubernetes orchestration. So anyone can basically via a few commands, they can basically uh, orchestrate a full headout environment on their laptops itself. And that's how our production and test environments also work. Um, Fault tolerant task offloading. We have testing automations, monitoring systems, and CI pipelines, RDBMS and NoSQL flavors, and some serverless magic which is happening. On the web side, like we are very proud of the fact that we are one of the first we were one of the first e-commerce single page applications, which was back in the day, um, during around 2015. um, Now we also have like server side rendering enabled, which makes our pages SEO friendly. A lot of different technologies that are used, like Next.js, React, Redux, TypeScript, Svelte, Node.js. We have been early adopters of PWA, Next.js, and React Native Web. We have edge caching enabled. We have our own in-house design language system, which we call Air. We have our internally built web templating engine, which is currently powering like 300 plus microsites out there. We have a lot of features that have been built around localization and accessibility. um, we have a lot of things around performance and data monitoring, which is done via Mixpanel and Sentry. We also have like SVG based seat map creation and rendering applications. and unit and integration UI testing. I'm just touch basing on these points very slightly. I mean, I can always go in depth on that, but like that'll take a lot of time. Um, on the app side, we have been featured by Apple and Play Store several times. When we started our app journey, we went the whole native route. But then we quickly understood that like going native route, although gives you performance, some edge performance benefits, but it's not really that productive because you have to build ecosystems for different apps or code base for different devices. So then currently we have completely shifted to React Native, and we are also experimenting with using React Native Web in certain pockets. And React Native Web is nothing but like a merger of bringing basically the React ecosystem and merging with web and the app. So basically, you can have a unified code base that can power both your web and your app, and it makes sense to go in that direction as long as like framework level support is there for most of the use cases. Because then if you share a design language, which we do, then it just makes sense to have like a singular code base which runs everything. But React Native Web is also new, so you can't just completely migrate to it. Like it takes time. So we are doing that like feature by feature as things progress. We have a shared design system with web. We have automated CI/CD pipelines using Bitrise. We have code push implementation whereby we don't by which we don't need to keep on publishing new apps for app updates. We can just push app updates out there. Um, Deep linking and attributions are done via branch and Mixpanel and some other things. Performance and data monitoring is implemented. We have smart push notifications via Web Engage, and it's our app has been one of the highest rated apps out there. Now, what's next, right? Like we talked about many interesting things that we have done, but what's next? So this is like a very small picture of like which merges like engineering and product, and there are so many things other out there. But just to mention a few, we are focusing on app plus web hybridization, which I basically talked about via using React Native Web. We do plan to, or we are interested to build an AI enabled concierge whereby people can just come up and ask questions, and the concierge is powered via GPT and has the know-how of our whole ecosystem and can guide people as to what their questions are. That they could be around travel, they could be around things that they want to book, they could be XYZ. Implementing recommendations and personalization. um, our supplier platform V2, basically we have a supplier platform that suppliers use to upload their content and manage their inventory and bookings. And we have like a upgraded version that we are currently working towards. Module federation front end architecture, whereby things will be modularized and can be imported in different code bases. Basically, components can be imported across different code bases. Um, Self-hosted open source CMS. So there are things in our front end which are basically powered by a CMS, and we are basically in the midst of implementing a new one, which is an open source self-hosted one, which is called Payload, and which will power our microsites. Dex, which is basically our word for digital experiences. And we like have a vision that going forward, we can enable a mechanism of digital experiences which will be AR enabled, so people can just go to Barcelona street and take a walking tour of Barcelona streets by just pointing their phone, and the phone basically guiding them towards, hey, walk towards this street, and you're looking at some place, and it's basically showing you images of how that particular building looked, like maybe a century ago or something like that. So like AR based experiences. Smart payment router, basically depending upon a lot of different parameters, we will smartly route the payment to the specific payment gateway that makes sense for the type of customer, where they are coming from and what city they are, what type of booking they are making, etc. Distributed multi-layered caching. This is basically caching that is enabled on a distributed set of nodes, which are basically load balanced, and they are multi-layered. So like you have the database at one layer, then you have Redis at one layer, then you have Redis will be outside of the JVM, and then you have like a JVM based cache, which is for Java ecosystem, which is in memory in the application itself, and canary deployments. But these are just a few mentionings. There are many more things out there. um all right, so who are we, like who are the people who are powering Headout? Again, like this is just a small set of people that I've been able to show in this small screen. But yeah, like we are like the engineering team over here is like 85 people strong, and the product team overall, which encompasses engineering, data, product, design, is around 120 people. And we are passionate builders. We like hard problem statements being thrown at us, and working towards that. Building on that, we are startup enthusiasts. We are very hungry for learning. We have a lot of experienced mentors out there. A lot of people have worked at different startups. They have worked in different positions over there. They have come out from really good colleges. And yeah, all we have like a mentality of always keeping on experimenting and with things. We do sometimes call ourselves as optimization freaks also. And yeah, we know how to have fun. So what does Headout truly believe in? Now, one of the thing is that all of the images that you will see in this presentation are images that are of people in our office, or are images from our current office or our previous offices. So this was one of the image that we had in our previous office. And uh, so we the different things, like we our different thought processes were embodied on this wall. And some of these are some of the things that we live and work by. I think time is less, so I need to roll fast. All right. So, what does the engineering culture look like? We are language and framework agnostic, as we mentioned beforehand. We strive for people having an exponential learning curve, and try to create an environment in which they can keep on growing. Be fast and experimental. Own and execute. We like to give people responsibilities, and them taking onus of things. Optimize for performance and stability. Automate as much as possible. Logical reasoning trumps everything. Like this is not a place. This is not a dictatorial place whereby someone says, "Hey, do X," and that's how it has to happen. You can always logically reason out on things. Flexible timings, and work with the best. And I would say work and have fun with the best. How do we like growth and learning is something which is very core to us. And we do a lot of things to enable that. We have something known as wasted tech Fridays. It's called wasted, but it's not wasted anymore. But these are basically sessions that we have every week within the team, where the whole team gathers up and talks about different topics, something that they might have learned, some new features that have developed in our engineering team or in the product, or just some interesting tech topics. We have product showcases every month, whereby features that are built are showcased to the entire company. We have something known as Headout University, which is just like an internal university learning thing. We like hackathons. That's why we do Hackout. And another version of that is Hackin, which is our internal hackathon that we have. And yeah, that also happens once in a year. Actually, different versions of that happen. Um, we have our engineering blog. We enable people can go ahead and do learning courses. Conferences and meetups are sponsored, and yeah, like we just have a lot of hard problem statements that people can grow and learn from. Some of the company cultural activities that happen, cultural activities are very important. One is like head outing, which is like a yearly complete company meetup that happens, whereby everyone gets together and discusses strategy, and every different team talks about what they have done in the past year and what they will be doing in the next year. A similar thing happens on a product level, which is our basically product vocation. We have team engagement activities. We have mental health and wellness support and workshops. A lot of celebrations that happen on the personal level, professional level, and or at different festive moments. We have quite some org-wide games that happen offline and online. We also have quite some games that have been happening during this Hackout week. Some treks, runs, and other fitness events, and a lot of quite some women exclusive sessions too. So cool stuff. What more, right? Um, Again, work from anywhere. This is basically an image by one of our employees, snapped in Hong Kong. He very very chill vibes and working out from over there. We have a flat org structure. I wouldn't call it completely flat. I would say as minimalist as possible. You will always have a structure as and as the company grows. And right now, I think our company is like 500 plus. But we keep the org structure as flat as possible, and we want like people to have the liberty to be able to go to anyone, even on the CXO's level, and just be able to question out on things and give suggestions. um, we have a rewarding culture, so we want people to work hard, and when they perform well, they are rewarded, and they well end up being happy. I hope that's been portrayed by the pic over here. And We have a global team. So I think like this image basically represents that we have people around the globe, not only in India, although a lot of people, most of the, like a big chunk of people are in India, but we have people around in Czech, in Germany, in Rome, in Amsterdam, Netherlands, we in London, in US, in Australia, etc. So we have a global presence, and we are a global company. And yeah, this is the pic from our last head outing, in which we gathered everyone from the company and had company level sessions. And yeah, that probably denotes the excitement that everyone has for the upcoming year every time we have head outing. So thank you very much for joining this session. Hope you had a good time, and hope you were able to learn and understand what head out is all about, and what head out's engineering and product culture is all about. So thank you so much, and yeah, meet you in the hackathon.
Great, thank you so much for that, Vikram, and I really appreciate you kicking us off today. Absolutely, we're global. I want to chime in on the global company though. Like that's what I'm trying to do. We have people everywhere between New York and New Zealand. We have teammates all over the world between New York and New Zealand, over 20 countries. Last time I counted, so it's a great team to be a part of. Thank you very much for that,
Yep.
Vikram. I appreciate the kickoff. Looking forward to seeing you pop up in the next day or two as well, as we go through the rest of our Hackout this year. Good. All right. Well,
Thank you,
everyone, thank you. We'll talk soon. So, don't want to waste too much time. I'll keep on rolling on. Our next speaker is ready to join us. Our next speaker is Neha Venugopal, who is coming to join us right now. To give you some background, Niha is the CTO at PayTM Insider and the SVP of Consumer Product and Engineering as well. So wearing many, many hats, keeps himself very, very busy. He's done everything from building the home automation software in Cristiano Ronaldo's house to running the box office at NH7 Weekender to managing stadium operations at Eden Gardens, speaking at ReactConf, and finally now running the product and engineering teams between the core PayTM app platform. A little interesting thing to know about Niha, though, is that he is also a failed drummer. He gave it a crack, didn't quite work out, but is convinced he'll do anything but computer engineering. So there is hope for all the failed musicians out there. There's something bigger waiting for you out there in the world. So Niha, can you hear me over there, fine?
Yep. I hope
Great,
I'm coming
thank you
through
so
loud and
much. How do you feel into engineering?
Yeah, I said I hope I'm coming through loud and clear.
Absolutely. Good. Well, take it away, and thank you so much for joining us.
Perfect. Cool. All right. Glad to be here. Glad to be speaking to all of you. I thought I'd give a slightly different talk today compared to sort of a lot of the talks that all of you might hear, which is usually around, hey, here's a tech stack that we use, here's a thing that happens, and give you a peek a little bit into some of the behind the scenes that happens when you're running engineering and product for something like a app used by 100 million users a month or 20-30 million users a day, and really the meta of how do you build apps and how do you build things for such a large org and for such a large company and for such a large user base is something that I thought would be an interesting thing to talk about because it's not usually something that's very often spoken about. Let me just quickly share my screen so that we're all on the same page. I hope this is visible. Perfect. Okay, cool. So let me talk through a little bit about what a super app is, right? And a lot of you would be, you'd be hearing this term. A lot of you would want to work, for places like Headout, for places like PayTM, for all sorts of interesting use cases. And we live in a world where a super app is essentially an amalgamation of all the things that you can do in life put together in one coherent app, right? And that's what PayTM is. That's what PhonePe is. That's what tons of them are. Got popular in China and is now everywhere that you see. And these are some stats. It's slightly outdated, but still humongous numbers of what we do at PayTM and sort of what is the engineering that goes behind it. And here's some interesting things about the way the actual shipping process works, right? And to me, it's one of the most fascinating things to imagine, and especially for a lot of you as you're figuring out how you'll enter the workspace and the kind of engineer that you want to be and the kind of products that you want to ship. The one thing that I always felt in my career that I really wanted to do was to work in a place where I could ship really, really fast. And the code that I wrote and the work that I did was in the hands of millions of people as soon as possible, right? And so, even though the PayTM super app is humongous, there's 400 engineers, there's a new app that comes out every 14 days, right? And that's like clockwork. That does not fail. That's absolutely golden. And this means managing, hundreds of engineers shipping so many different commits, so many different product features. And this isn't even the stuff that gets released without having an app release. And I'll talk a little bit about some of the tech behind that as well. And then, and there's 100+ daily internal builds and there's continuous releases of tons of non-native code that keeps happening. What are some of the problem statements when you're trying to engineer a super app, right? Or when you're trying to solve or build an engineering org or be a part of an engineering org behind a super app, which is so phenomenally large. So there's 4 broad buckets, right? There's a lot of diversity of devices and use cases. And that's something that front-end engineers especially really have to sort of work on, which is very distinguished from back-end engineering. And I really don't like these artificial divides, but in some cases it makes sense. Back-end engineering tends to be a very homogenized environment, a very steady state environment. You know exactly what machines you're working on, exactly what the capabilities of those are. It's very, very deterministic. But your domain modeling and the variety of things you need to solve are massive. Everything from databases to queues, to real-time logging, there's tons of different things. Front-end engineering is a bit narrower in the sense of the kind of domain knowledge and the kind of domain modeling and business logic that you'd like to put in. But it's offset, and there's no such thing as a free lunch when it comes to building products or engineering. It's offset by the fact that, if you can think of the worst possible device that you're absolutely sure you would never use in your life ever, a mobile phone that is 7 years old, is running Android 5, has like lesser RAM than what your first PC was when you were 3 years old, and you would think that a device like that would never be used, and then you'll log into a dashboard and you'll see there's 6 million people using that phone, and you have to build for that, right? So there's a lot of that with front-end engineering. You also really want to sort of release rapidly. You don't want to be stuck in a case or in a place of saying that, hey, I have too many engineers, I have too many different problem statements. It's going to take me, a very long time to be able to release my code. Because the number one thing that matters, from an engineering and a code building perspective is very much so the feeling of satisfaction of having your work be used. Whether it's be used by other teams, whether it's be used by consumers, whether it's being used as an open source platform, it doesn't matter. And if you're working in an org or if you're working in the kind of environment where you write some code and then 4 months later it's being released, there's absolutely no satisfaction in that. The other part of building at scale, right, is also how do you have strong opinions loosely held, right? And I'll elaborate on this principle because it's a very core principle for how we do engineering and how do I do engineering as well. And then how do you build centralized when your org is decentralized, right? And some of you, might have experimented with Web3 and decentralized orgs and so on and so forth. And that's not the kind of decentralization I'm talking about. But largely, you will end up finding yourself as you grow in your career in teams and in engineering processes where your final output is very centralized. Which is at the end of the day, if you're a Paytm customer, you're using the Paytm app, right? There is only one product that you're using. But there is, hundreds of teams behind that who all run on their own independent schedule. So how do you sort of manage all of that? So diversity of devices becomes something that's phenomenally important. And it's something that from an engineering perspective, right, as a lot of you will be building your chops with it, is something that's one of the most fun things to work on. It's simultaneously incredibly frustrating, but it's also incredibly rewarding because there are two kinds of performance optimizations, right? And Vikram was talking about really being optimization driven. There's two kinds of performance optimizations that you can do, right? There's performance optimization on a steady state, right? You know what you're working on and how can I extract the maximum from it, right? I know my database is running on 6-core, 64 gig machine, whatever it might be. How do I sort of make sure that my queries are running in the smallest possible time, or the multi-threaded code that I've written is doing the least amount of context switching between different threads? It could be a number of things. But then there's a different kind of performance optimization, which is not necessarily, which front-end engineers are a lot more familiar with, which is what is the lowest common denominator of performance you can have, right? Which is if you start building for the worst device that you have, do you then harm the experience of your best users who are on their best phones or on, have very powerful machines or so on and so forth? And if you, on the other hand, say, hey, it's not worth the effort, I'm just going to build something cool, I'm just going to write code, whether it's Android code, iOS code, React code, doesn't matter, but I'm just going to write code and it runs fine on my machine, it runs fine on my phone and 3 of my friends' phone, I'm good with it. Well, then you're disadvantaging a great number of your users, right? So it requires a very different kind of mindset when it comes to performance engineering. And as engineers, we love nothing more than problem solving, and it's one of the most unique classes of problems that exists out there. And it's a lot of fun to solve that. At Paytm, we solve it in a lot of different ways. We solve it by having humongous instrumentation. We log petabytes of logging events and telemetry across, hundreds of millions of devices. So we know exactly what's going wrong. One of the few things, for example, that I know that, I can talk about is the fact that the vast majority of mobile OSs in this country, right? Especially your Vivo, Oppo, a lot of these slightly cheaper Chinese branded phones, they all lie. They all lie humongously about how much RAM they have, how much CPU they have, how much XYZ things that you have. So forget about like marketing material being lying when you're looking to buy a new phone and you read all this fancy marketing about a phone has all of this type of hardware. You assume that marketing is always a bit of a lie. But then when you actually start writing code for some of these use cases, you find out just how much they lie, right? So it's always fun to find that out. It's also very interesting to be in an engineering org and to work as an engineer and build the kind of habits that allow you to release rapidly. And a lot of people think that releasing rapidly means degrading quality in some way, or moving fast, and it's okay if some stuff breaks, we can come back. The very dichotomy, or the very distinction that you can move fast, but you compromise on quality in some way is a very futile endeavor. They're not mutually exclusive. You can be an engineer who writes really, really good code, which is extremely high quality, has fantastic tests, does not cause any sort of issues, and is as bug free as you can imagine it in your head, and you can ship very, very rapidly. A lot of these things are less about the individual characteristics of the person and more about the org itself, and more about what the org can ship. So it'd be fantastic if all of you imbibed some of the habits that led to this sort of a development workflow, right? The number one thing for that would be to be extremely test driven, to use tests as a mechanism for safeguarding the quality of what you're doing and give you the confidence. The second would be for you to commit code very frequently and very, very rapidly. Don't have super long-lived branches in your Git workflow. Build all the automation, whether it's continuous integration, continuous development, whatever it might be, so that your code gets out as quickly as possible with as much automation baked into it as possible. And a lot of that means, and a lot of you would be doing your own side projects. Some of you would want to start your own thing. Some of you will do it at places like Headout and at other places that you join. And a lot of you would find that doing this requires a certain amount of discipline. Operating in this mode requires a certain amount of prep work. You have to do a bunch of things ahead of time before you can actually write a lot of good, great code. And for a lot of people, that's what stops them from working in a very test-driven, rapid, but high-quality manner. But trust me, if that's the modus operandi that you imbibe, and that's how you would like to ship code, it's very easy to be a 10x engineer by doing that. It's also very important to have strong opinions loosely held. And this is a very, very important guiding principle for any engineer, in my opinion, which is you should have really strong opinions. You should be, and obviously these opinions should be based on your understanding of the code, your understanding of the problem statement, your understanding of what you think is architecturally correct, what you think is the right way to build something. Maybe you've read about it somewhere, maybe you saw a talk somewhere, maybe you watched a YouTube video, you saw someone live stream a piece of code and you think that's the right way to build it. Then by all means, have strong opinions and be very vigorous about understanding why you have these strong opinions. But make sure that those strong opinions are loosely held. And what I mean by the loosely held bit is that if you see data, or if you see a better way to do things, ignore your priors, ignore and be very loose with saying, okay, I used to think that, writing functional programming is the best way to do engineering forever and ever and ever, and that's the only thing I will do with my whole life. And then you encounter a problem statement, or you encounter a domain where, okay, maybe imperative programming or a particularly different programming style might suit that problem better. And if you really sort of put aside your assumptions of what you think you're ideologically committed to, and engineers are very, very ideologically committed to what we think is right, it'll help you be a much better engineer if you're able to sort of change with that. So it seems like a bit of a, how can you do both at the same time? But that's the trick to being a fantastic and productive, and successful computer engineer, is to have strong opinions which are loosely held. And here's a quick example. I don't want to go into too much detail because I know there's a lot for you folks today. But here's an example of how to build centralized when the org is decentralized. And at Paytm, for example, we have the UPI team, which is regulated by the Reserve Bank of India, by NPCI. It's built by Paytm Payments Bank, which is a different organization, and it's a different regulated entity completely. And it has radically different ways for how products should be built, right? If you ever work in a fintech, or if you ever work in a bank, you can't just write code and release it. It has to go through 8 layers of approval. It has to go through 9 committees. It's a very complicated process. And it's a process that exists for a reason, because you're dealing with people's money. You can't just ship code and then assume that, hey, there was a bug in my code. I'm sorry. All the money from everyone's account came into my account. I don't know how that happened. You can't do stuff like that, right? So it's very important. And that's a very different workflow. Then there's something like bill payments. Or recharging your mobile phone on Paytm, which is very different. It's a very digital product. We keep iterating on the UI for it. It's very, very dependent on sort of how we want to build the experience. It's a very mature product. We do a lot of experimentation. There's a lot of data science, A/B testing, things of that nature, right? And then we have something called, like platform engineering in the middle. which is sort of the foundation of how all these different companies or how these different orgs work. And really what's fascinating to me is that none of these have a common way of writing code or a common way of deploying or a common way of, okay, these are the kind of people who should be working here. And at the end of the day, it's all engineering, but it has different flavors of engineering. And it's really important to have a curious and open mind to figure out what flavor of engineering is for you and what flavor of engineering is something that you enjoy. I'm going to talk about some of the solutions of how we deal with it and how I deal with it at Paytm. And these are in general sort of some rules of thumb, and they're more meant for the org, but they also apply to individual engineers, especially some when you're starting out in your career. A lot of the times you'll be working on problem statements where, as you get more experienced and as you figure out, hey, I was working in domain X last year, now I'm working in domain Y, or I was working on this particular microservice, now I'm working on this microservice, or I was working on this particular product feature, now I'm working on this product feature. You'll keep finding that context switching is hard, but what's more important than context switching and getting lost and saying, hey, now I'm working on a different problem statement, I have forgotten sort of what I had learned earlier, is to actually do pattern matching. Is to say, hey, across these different problem statements that I'm solving, and this could span all the way from your college projects to open source work that you do, to the engineering work that you do. Is there underlying things that I'm finding which are common? Is there underlying learnings that I'm having about, hey, this pattern sort of makes sense to me. Hey, in the last 3 problem statements that I solved, they would be much easier to solve if I had a tool like this, or if I had an abstraction like that. And really, it's that iterative pattern of, as you solve different problems and you build that abstraction and pattern matching within yourself, that makes you a significantly better engineer. The second part of it is also developer productivity. It's something that a lot of orgs don't necessarily focus as much time on, and it's something that people sometimes end up taking for granted. But being productive is phenomenally important, right? Especially as engineers, you're all going to be, let's be honest, you're all going to be highly paid. You're all going to be doing decently well in life, and your time is valuable, right? There's only so much that you can do with your time. And therefore your productivity becomes really important, right? And so optimizing for your productivity, right, is something that needs to be imbibed into the way that you do your daily life and your daily work. Now, optimizing productivity a year and a half or 2 years ago meant, hey, can we make sure that you're writing your code and it's peer reviewed super quickly and it's in the queue for it to be released super quickly, and you feel like, hey, I'm being super productive. My work got released. I got immediate feedback. I went through some dashboard. I figured out my code was slow. I'm able to fix it. And I'm in that rapid sort of zone of making changes. But productivity also means, for example, using tools like Copilot, or using tools like, all the Gen AI tools to be able to be more productive. So it's really important to understand, the trade-off between, I want to spend a lot of my time making myself more productive, and then I want to spend my time doing the actual work. And it's important for you to think through that trade-off, because I've seen so many engineers feel like, hey, when I was in college and, when I was doing my college projects, code was so super quick. I'd just do it, I'd compile, I'd see the result on my laptop, I'd feel really good about it, and then I'd keep making changes on it, and it felt like a great loop. And then I joined an org, and then their stuff started getting more and more slow. A lot of the times that's the org, but a lot of the times that's also you, right? Because being productive, being someone who understands how to make yourself faster is a continuous iterative process. Only some of that is something that the org can do for you, but a lot of that you have to do for yourself. There's also a fear of change. And this is something that a lot of you will encounter, especially if you're not working on 0 to 1 products. If you're working on products where you've come into an existing team and you're working on existing sort of solutions, there's always a fear of change, right? Okay, don't touch this layer. Right? Don't touch the data layer, right? It's there's too many, like last time jab bhi kiya tha to fat gaya tha sab kuch, whatever it might be, right? So it's very important to understand, where does your fear of change lie, whether it's with your personal projects, whether it's with your own, the way that you code or the way that you think about architecture. There's always be places where there's a fear of change. Identifying them and then saying, okay, cool, how do I fix it? How do I make this better is a very important part of this process as well. Then there's also, something very important, which is when you start building for the real world, right? One of the things you always learn is that there are unknown unknowns, right? And this is a very classic matrix, saying you have known knowns, which is, there are problems and you know what those problems are. And then there are known unknowns, right? There are problems, but you don't exactly know what those problems are. So for example, a known known everyone understands. A known unknown would be, I know, for example, that across the millions of devices that Paytm is running on, there will be some devices on which my app will run really bad, right? It's going to run really slow. It's going to be non-performant. I know that that's going to happen. I don't know which devices those are, right? And so you build a mental framework with saying, okay, if I know that this is going to be a problem, but I don't know what the problem is or where the problem lies, how can I solve for it? Then there's also the unknown unknowns. You had no idea. You shipped something, you released it, and then everything broke. Or something broke somewhere, or some bug got introduced somewhere that you have absolutely no idea about. And that's really what causes the most amount of stress as an engineer, is the unknown unknowns. You had no idea. And so really, do you have a feedback loop in your product, in your engineering, in the way that you build software to convert the unknown unknowns into known unknowns? You should have an unknown unknown only once. Right? The first time there's been an unknown unknown and you've learned that, okay, my database layer has a problem where, if I send too many queries, my SQL proxy layer gets choked. Okay, you learned that the first time, you didn't know that, now you know, right? Now you may not know yet what type of queries or what type of traffic patterns cause this service to go down, but you do know this service is fragile. Then you can start working on it. Then now you say, okay, if it's a known unknown, can I start putting instrumentation around it? Can I start putting telemetry around it? Can I start doing intelligent things around it? And that's really sort of the way to figure out how to make this happen. Cool. So I'm going to run through, the way at Paytm we solve some of this in terms of these principles. At Paytm, we're broadly divided into 3 app engineering teams. We have the core app engineering team, which is the for engineers, by engineers. It's staffed by principal engineers. This is where a lot of the deep platform thinking happens. We have the central app engineering on top of it, which builds all the abstractions for everyone else to use. That could be UI libraries, that could be data fetching libraries, that could be backend proxy layers. And then finally, we have what we call vertical app engineering, which is the teams that are responsible for bill payments, for how do you pay someone, how do you scan and pay, and all these sort of very specialized use cases. I very quickly will run through the tech because I know we're short on time, but roughly the way that we work at Paytm is that we have native code on the app, which is predominantly used for our daily sort of use cases, as well as for things like OS interactions. For example, your camera, how do you scan a QR with your camera, is very much native Android or Swift code that's written out, whether it's in Kotlin or in Swift or whatever. And then for a lot of our other use cases, for example, how do you book movie tickets? How do you recharge a mobile phone? A lot of these use cases are not necessarily daily use cases. They're used maybe once in a month. So for that, we have our own in-house framework. That's one of the teams that I lead, and I built this architecture. It's sort of our own homegrown version of React Native. It's called Phoenix, which basically allows us to take HTML and JavaScript code, run through a compiler, and then outputs native code on top of it, which can then be iterated on without needing to release an app, right? So from behind the scenes, we can change the whole UI, we can change tons of things, and so on and so forth. And on top of both of these, sits a system called Storefront, where Storefront is essentially a UI as a service platform. That's what we use, where every single pixel that you see, if you were to open the Paytm app right now, almost every single pixel that you would see on the app is actually being generated by a backend service. And the backend service does a lot of data crunching. It has tons of models behind it. It has a lot of deterministic code, and it puts all of that together to give you a very personalized and sort of changeable UI experience. And at any point in time at Paytm, for example, we're running about hundreds of experiments with about 120 million people without any of them knowing, where we change a few things, we try out new features, we roll them out, and no one's the wiser, and that's how we learn. A couple of things, again, it's fairly high level, but important is to have a hierarchy of importance for when you're building a super app, right? And say that, hey, when I'm building my engineering architecture, what's the hierarchy of importance for the principles that I apply in my architecture, right? So for example, some of the principles that we have tons of different trade-offs. We say, look, if we're going to build a new feature on the app, but that's going to increase the download size, should we do it or should we not do it? Because India is a very download size sensitive market. You can't have an app that's 300 MB, for example. And so we establish a hierarchy. We say that, look, if this product feature is something that's going to be used every single day, we'll allow it to be, we'll allow the download size to increase. If this product feature is going to be infrequently used, well, then build it using our Phoenix framework, where it's actually not part of the native code that's downloaded, but it's downloaded on demand using HTML and JavaScript, right? When you're working on UI, for example, or you're building a product, What is the trade-off between iteration speed? Do I build an MVP? Do I ship it really quickly? Do I make sure that my users are using it and get real feedback? Versus craftsmanship. Does the product look good? Does it feel good? Does it have animations? Does it give you an emotional connect with what you're building? And that trade-off is also very important to establish in your head when you're building. And please don't think that just because you'll be joining large orgs that as engineers, you don't have to think about these things. You absolutely need to. A phenomenal engineer thinks about every single trade-off that goes into the product at every single point in time, even if it's outside their specific engineering team, right? What does the shipping speed look like? How much guardrails do I put? How do I make sure that, my product doesn't suffer with quality, but also how do I make sure that I'm not taking 6 months to write a new microservice that I should have written out in 2 weeks? So it's very important to ask yourself these trade-offs and have a guiding principle for how you would like to build some of these. Don't ship your org structure. Again, doesn't necessarily apply to you folks when you're joining and relatively new, but it's really important. It's very, a lot of the times you'll join companies and you'll join orgs where the team structure determines the platform architecture. Right? And that's absolutely the wrong way to build it, or it should be the other way around in a lot of ways. So it's very important to have a mindset of the kind of abstractions you would like to build, so that it's always fun, right? Like to say that, hey, across these 3 teams, we need an abstraction, or we need this new microservice in the middle, or we need something in the middle to be able to sort of, for all of us to do our work effectively. So that becomes really important for you to imbibe. There's a lot of, when you adopt this sort of way of building, you end up needing very flexible teams, right? And it has a second order effect of very flexible teams. You should always aim to be someone who's a very flexible engineer. That doesn't mean that you can only be a generalist and you can't be a specialist. Flexibility and specialization are actually 2 different things. Flexibility means that you should know when to sort of build an abstraction, but flexibility also means you should know when to optimize for time to market and to build something really quickly. And that really comes when you have empathy and you have understanding of what the whole org is doing as an engineer. There's also a lot of dissonance in being in building apps in such large teams, which is that a lot of engineers tend to become really good solutioning people, right? And a lot of you would have already felt that through the course of how college was, and through the course of as you start entering into this, which is you've always enjoyed problem solving, right? And so you really enjoy being that person who can say that, okay, here's a problem statement, we have these 3 services, or we have this sort of PRD that needs to be done. What is the best way to build it? I can draw something out on the whiteboard. I can build something out. I'm really the solutioning building person, right? And what tends to happen is, if you're someone who's really good at solutioning, and if you're someone really good at problem solving, it sort of automatically gives you the ability to move up the ladder a little faster. But solutioning expertise is not platform expertise. And what do I mean by that? Someone who's fantastic at designing a solution is a little different from someone who, for example, understands database internals really, really, really well and is a platform expert and can bring in their knowledge into it. So as you grow your career and as you understand the kind of engineer that you want to be, it's also important to understand how you'd like to go. Would you like being the solutioning person, or do you like being the sort of super specialized in understanding, hey, I understand React really well. I understand Gen AI really well. I understand how to build LLMs really well, better than anyone else. And that's sort of going to be my expertise, right? And the last thing, before I wrap this up, would be that there's a very high degree of trust needed in the kind of abstractions that you build in a super app. If you're building, say, the UI as a service that I was talking about, that's used by 120 million people, that is used by hundreds of engineers internally, there's a high degree of trust that needs to be built. And a lot of engineers, especially when you're starting out, you assume that the trust in your code and the trust in what you're building happens because of the technical correctness and superiority of your code. That's not always true. When you join an org and when you're working in large teams, the way you communicate, the frequency of your communication, and how willing you are to talk about the code that you've written, how willing you are to talk about and to listen to other people in, about what they're building, that is what builds a very high degree of trust in what you're doing and the abstractions that you're building, right? That's sort of more or less the flavor that I wanted to give you folks of the kind of things that happen behind the scenes at Paytm. If you have a Q&A, if you have time for that, happy to answer a Q&A. There's some more stuff that I can talk about, but I really don't want to take up too much time. So yeah, thank you for having me.
Thank you very much, Neha. Appreciate that. We have some time for some questions. That's okay with you.
Sure.
If you haven't noticed, everyone, feel free to post your questions and here right there in YouTube. We'll through the stream chat, and we'll ask that to the speakers throughout the day when we have time to cover that content. But we do have a bit of time right now. So Tamish asks, can your minimum viable product just be a pipeline of codes that we can represent through a screen recording?
I would very strongly advise against that. And the reason I would advise against that is it depends on what you're trying to make your product viable for. If you're trying to make it viable to pitch someone to get money, right, for seed funding or something, then sure, share a screen recording. But the real feedback loop that happens with any product is when you see real users using it. Otherwise, it's just an abstract notion. It's the difference between, hey, we all like the idea of an iPhone, and you can see all the glitzy TV ads about an iPhone, or see Instagram posts about an iPhone. But till the time that you use it in your hand and you see how it feels, you won't actually fall in love with the product, right? So my recommendation always would be, it doesn't matter if it's only 3 people, but get your product in the hands of real users, see how they're using it, and use that as the basis for your MVP.
Wonderful. Thank you very much for that. We also have another question from Vikram, actually. So what are some of the methodologies, engineering or product or processes for shipping fast but not breaking things?
Sure.
The big question in tech.
Yeah, there's a couple of things, right? The first would be the way your code processes works. By that, I mean the way you're committing code, the way you're branching code. So broadly, across companies, you'll find 2 different ways that code works, right? The first is trunk-based branching, where, say, you have a product that releases every 2 weeks, right? And then what will happen is, before the 2 weeks, there'll be a release team, and the release team will create a new Git branch. And they'll say, hey, everyone who wants their code to go out in this release, please put your code in this Git branch. And then what happens then is that you end up having these very long release cycles where hundreds of engineers are trying to commit code, and you find that, hey, the code that I'm writing is clashing with your code because I was writing my code in my own silo for 5 days. Then when I come to submit my code, it starts clashing with your code. And then we spend a lot of time solving merge conflicts. I'm sure people have also dealt with merge conflicts in your own college projects. And you spend a lot of time dealing with those kind of things, right? So trunk-based branching works when you don't trust the engineers and you really need that release and quality control process where everything goes into a gatekeeper and then the gatekeeper decides what needs to go out. The other way of doing it, which helps to go really, really fast in terms of shipping, is essentially to do really, really small branches, is to commit to, for example, master branch very, very frequently, is to have all the automation built in so that you can write your code and at the end of your day, just submit that code and have it be patched in without worrying about, hey, have I broken something? Because you have tons of tests, you have tons of automation to make sure that nothing is breaking. When you adopt that sort of a process where as you write code, even if it's incomplete, you can submit that in and you can release very, very quickly with it, you end up finding that you solve that loop of how do I move fast and I don't break things, right? This is an example, I spoke about some of the native code on Paytm side, which releases every 2 weeks. I would say about 80% of the code on the Paytm app is actually not native code. It's HTML and JavaScript code through our own internal framework. And about 80% of that code across 400 engineers, at least 50 times a day is being released to 100 million, right? There is no release process for it. But you don't hear about, hey, my Paytm app stopped working, or hey, this happened. That's because all of this automation and tooling exists. And we encourage people to say, hey, you came in the morning, you wrote some code, ship it out in the night, right? And you can put it behind a flag, you can put it behind some tooling that says, hey, ship the code out, don't switch it on, right? And then the next day you can come back, iterate on top of it, ship it out, don't switch it on. Then when you feel like it's ready, switch it on, right? So those are some of the ways. I can go on and on about this, but there's tons of different ways to do this.
Thank you very much. If we had more time, I'd love to hear more about this topic for sure. I just wanted to put it back out to the team. Do we have any further questions? Before we wrap it up, we have a little bit more time with Neha if you want to get some answers out from his expertise. But while the audience thinks about that, Neha, I just wanted to question, is there one bit of gem of wisdom that you would love everyone to walk away with
Sure.
from all that you covered today? Something they could really walk away and say,
Sure.
this is the nugget that I want to take home.
Sure. I think if you're a young computer engineer or just engineer in general and you want to do programming, you want to do all these interesting things, the one thing that's needed above everything else is curiosity, an incredible amount of curiosity. You should have a goal for yourself saying in the next 2-3 years of my life, I am going to learn X, so many programming languages. I'm going to build so many different systems. I'm going to try 18 different architectures. I'm going to try building 7 different MVPs. I'm going to try everything under the sun because you're just starting out. I have no idea. Most probably you have no idea what your life, your career is going to look like a decade from now, where you will be working, in what country you'll be working, what problems you'll be solving. But the one universality that I can guarantee is that if you're hungry and you're curious, you'll end up becoming the kind of person that 10 years from now will be really successful.
Thank you very much, Neha. And definitely echo that. Stay hungry, and they'll definitely drive you through your career. Thanks, Neha, and absolute pleasure having you here with us.
Thank you so much.
Hackout this year.
Cheers. Take care, everyone. Bye-bye.
Bye-bye. All right, everyone. I hope you all really enjoyed the presentation of Neha. We're going to roll right along and introduce Shyam Krishna, who's the principal engineer for Netrodyne. He's an experienced software engineer. He's got lots of skills in various platforms: Java, Spring, databases, algorithms, programming. There's very little that Shyam hasn't been involved in, to be quite honest. But something that you might find interesting about him is that he loves clean code, loves Reddit, and loves trekking as well.
Yeah.
He's a big fan of Murakami and loves finding sense in those everlasting meanings, which I'm pretty sure all of us who work professionally can definitely agree with that. We love to find a purpose in all the meetings that we have to sit in all day. But Shyam, thank you so much for joining us.
Yeah, thanks for having me.
Great, we can hear you loud and clear. So everyone enjoy the presentation with Shyam, and I'll touch back in when you finish.
Sure. Hey, hi everyone. I would like to first thank the Headout team for this opportunity and my friend Charles for introducing me to them. So today I would like to talk about so primarily database logs and transactions. So that is the topic I would like to discuss. So since I understand most of the audience here are primarily people graduating, so I'll try to cover the basics first before heading into some use cases. Okay, I hope we'll have enough time. Let me share my screen. Just a minute. Okay, can you guys see my screen? Hello?
No, not yet.
Okay.
Can you share your screen with from the share button here, like the channel?
Yeah, just give me a minute.
Yeah. No, not yet.
Let me retry again. Okay. Can you guys see it now? Hello.
Yeah, we can. Yeah, we can.
Okay, great. Yeah, thanks for the confirmation. So yeah, so I would like to discuss about the database logs and transactions. So I think primarily transactions are something I think we mainly hear in the banking domain, right? So wherever you do any account credit or debit related operations, so there we generally hear it as a transaction. So there are some certain properties around the transactions which I think most of the database adheres to. So I think I would kind of sorry. Yeah. So transaction is basically a set of statements, the SQL statements that we execute on the database, and they kind of enable us to perform operations related to the product. So generally most of the databases somewhere or the other support ACID properties, right? So which are like the atomicity, consistency, isolation, and durability. So transaction enable us to achieve these properties. So I would kind of compare this to Git branching. So whenever you have a master or release branch, right? So you have to work on a new feature. You kind of take out a branch, you do your changes and commit back, right? Merge back. So transactions are something similar to what you do with a feature branch. So where one of the primary thing is when you're working on this, you don't know whether finally the changes are going to be merged back to your master or release branch, right? So it might actually get deprecated as well. And the other thing is when you are doing the changes, these are primarily as a draft version. They don't necessarily go into the so they don't actually till you merge back. So nobody else should be able to see the changes. So these are, I think, this is where the whole principles of transaction come into picture. So just like how banking account management, you have, for example, Book My Show, right? So where you have a theater and you have some seats. Any user can actually come and select any seat and book a specific seat, right? As soon as he selects it, after that they have to do the payment. So we don't know whether the payment is going to go through or not, right? So which are dependent on various other things. But till that time, you want the seat to be booked. You don't want multiple people booking the same seat, right? And similarly, if you take about IRCTC, right? So most of the, I think, folks would have came across Tatkal booking in the past. So there you have which incurs a huge amount of concurrency as well. So there you have like some millions of transactions trying to operate on some specific shared resources, right? So I think these are like various places where we have a high amount of contention for a limited resources. So all these things are need to be somehow managed and supported, and this is where transactions come into picture. And apart from transactions, the logs also play a critical role. So whenever you select a seat in a specific theater, right? So your expectation is nobody else should be able to select the same seat till your operation is either successful or failure, right? I think this is where this is kind of an explanation of how locking happens. And and in case of account transfer, right? So if you're like, let's say, transferring some amount from your account to some XYZ person's account, right? So ideally you'll be debiting your account with some amount, and you'll be adding up the same amount to to your friend, right? So this operation has to be atomic in nature, because you can't actually so it won't work out if the amount is deducted from you but doesn't actually reach your friend, right? So that shouldn't be a consistent state. So you want the entire statements to be atomic, either completely done or completely rolled back. It's not good to have something hanging in between, and that is what atomicity talks about. And consistency is in case of Book My Show, if a specific seat is actually booked, right? You want it to be booked, shown as booked to everyone, and the vice versa as well. If some seat is available, you don't want a specific set of people to show it as see it as available, and someone else to see it as booked at the same time, right? So you want to be fair to all your audience. So as part of that, your data has to be consistent, or at least in most of the cases. So there are some scenarios where you can play around with this consistency, and that is where, and it kind of gives a lot of trade-offs around how you can orchestrate your whole DB setup. So yeah, I think that is what consistency is. And isolation is if there are multiple people booking. For example, you're booking some one of the seat, and some other person is booking a different seat altogether. You want these transactions to be completely isolated in nature by default, right? You just because you are booking so there is no need for these transactions to be interlinked unless you are operating on the same resource, right? So that's what isolation actually refers to. You have so the transactions has various mechanism of properties which enables you to achieve these isolations. Okay? So logs are, at the end of the day, these are kind of the building blocks for the transactions. And most of the transaction operators we use are like begin, flush, commit, and rollback. Begin is when you actually start the transaction, and that's where the DB kind of registers and kind of ensures all the operations are performed. And post that, you have a flush operation where you can actually interimly send whatever statements are present. And you have a commit, which is basically the end of transaction. So the moment you commit, all the changes that you have done so far has to be updated back to the database. So that will become the mainstream changes. So till then, you can consider this like a draft. So one of the reasons why you have flush and commit are, like, for example, you have a identifier, you are doing an insert, right? So ideally your expectation is it should return some kind of identifier based on some sequence generator, right? So these identifiers might be you might be actually storing them or using them subsequently in your transaction. So in these cases, the flush actually helps, and there could be some kind of conflicting statements within the same transaction as well. So those kind of things can also be weeded out from the flush statement. And the rollback is whenever there's an error, automatically by default the transactions get rolled back. If it is not an ideal state, so if there's an error or exception, right? So the entire transaction default rolls back. Okay. So yeah, this is the transaction overview. Yeah, I'll probably take the questions at the end. Yeah. So for database, we will use Postgres for our whole references. I think most of these concepts are kind of applicable for Postgres, MySQL, MS SQL, any of the databases. There'll be slight modifications, although, but at a crux, I think like 90-95% of the concepts would remain the same. Like different databases make different choices to access this data, right? Or implement these, how they handle the error situations and all. So because of that, there could be some differences, but primarily the concept remains the same. So yeah, we'll discuss about the types of reads. So reads are, so you have a dirty read, which is like, as I mentioned, you have a transaction can be either committed or rollback, right? Or it could be kind of happening ongoing. Till it is committed, so in case of rollback or committed, you kind of consider it as a complete state, right? So anything which is ongoing is kind of considered as an uncommitted state. So dirty reads are basically where like one user is trying to read data, and kind of has written a data. Let's say if user one has updated an account with some XYZ balance, and user two is trying to read the data, right? So in that case, ideally, since it is not committed, your expectation is you don't want the data to be read by other transactions, but there could be scenarios where you want to have this. So this is called a dirty read, and this is the least isolation levels that you generally get. So apart from this, there is a non-repeatable read, which is where so basically I actually yeah, let's consider a situation where I try to see the number of seats that are booked in a theater. So let's say I try to run a query in a transaction at time t, okay, time t1. I queried how many seats are actually booked in a specific theater hall, and after 5 seconds or something, I do some other XYZ operation. I'd come back, I run the same query again. So in this 5-second duration, there is a possibility that some other person could have booked the seats, right? So in this scenario, the number of the data that we read will be different because it's something that's constantly getting changed, right? The non-repeatable read is basically where you execute the same query, but you see that the data is actually been modified. So that is there, and that is a non-repeatable read. And phantom reads are basically within a transaction you execute the same query, and you see that there is a different records altogether. There's some new records that are inserted, which is, let's say you have a use case where you want to see what all purchases you have done and a user has done in last 1 day. So the moment you actually rerun the query, your definition of last 1 day might change, right? That is one. And second is the user could have done some more new transactions where you have now new entries in the when you actually execute the same query again, right? So this is a phantom read. So this deals with new or deleted. It's also possible that some of the records could be deleted in a different use case. And the serialization anomaly is basically this is a tricky part to understand compared to rest of the things. So there could be a case scenarios where, like although all the transactions kind of end up being successful, there is a situations where your final state could be inconsistent depending on the order of these transactions. You performing multiple transactions, right? So if these transactions are done in a different order, your final state might be changed. So I'll probably explain about this a little later. So this is the types of reads, and you have a transaction isolation. So this is where you kind of so these are definitions on how what kind of read will be there. So the transaction isolation kind of allows a user to define how the read should be. So now I think these are kind of interrelated to what the types of reads. So read uncommitted is one of the least stricter in nature. This is one of the isolation level. So where basically any transaction can read anything, even though uncommitted transaction, including the uncommitted transactions, right? And read committed is the default one, default isolation which most of the users provide, most of the databases provide. So this is basically only when the transaction is committed, you are expected to read the data, right? So this is the default isolation. And the repeatable reads are basically you have a this actually reads the data which is committed. So basically read committed actually at any point of time in the transaction you query data, right? So it actually uses the data of the latest committed transactions as well, correct? But at some point, sometimes you don't actually want that. You want to kind of retain the state at which the transaction begins. So you don't want, like, from the time the transaction begin to the time you are running the query, right? There could be some other transaction that would have been committed, but your expectation is you don't want that happening. So in this case, you can actually use a repeatable read isolation where DB ensures that any data that you try to access is actually pertain to the state of the database when the transaction began. Okay, so this kind of ignores any committed transactions as well from the time you start. So this is obviously more stricter in nature compared to the first two. And the fourth one is basically the most strictest in nature, which is a serializable isolation. This kind of ensures these transactions are kind of executed in a serial nature and not in the typical concurrent fashion. So this obviously is the heaviest with respect to compute or the maintenance. And but this will ensure your data consistency is like the highest level. This also enables avoids anomalies, other anomalies, and there is so there is a possibility, like post the transaction is committed, also this retains a state of the transaction, so that so that it kind of ensures these anomalies doesn't happen for the subsequent transactions to come. So that's why this is one of the reasons why this is has higher maintenance and also less preferred because of high compute. And the other additional options is the serializable only read-only differable. So this is one of the options when you actually execute your query, right? So whenever there is an anomaly detected, there is a possible serialization anomaly that can happen. So you have an option. You either have to take a call whether the other transaction should fail or should block. So by default, the serializable isolation ensures the transaction fail. Like for example, In first transaction, you updated some record. In another transaction, you are trying to update the same record, and you committed the data, right? So at this point of time, your transaction will actually by default just breaks up, saying there is a concurrent update happened on the same by a different transaction, right? So this here, like there is so this is the serialization anomaly, and there is an additional option where you can actually say that, so you can actually, if there is another update happening on the same transaction, right? You can actually say that the second transaction has to wait till the first one is complete. So this is another, or when you're performing the read also, it's the same thing. So both 3 and 4 repeatable reads and serializable isolations results in some errors like the concurrent update, and this requires a retry mechanism from the application side. Okay. Yeah. So yeah, isolation and read. So yeah, so this is, I think, kind of similar to what I covered in first and two. So this gives a combination of what all can be done and what can't be done. So Postgres doesn't actually provide like support this read uncommitted at all, because that's not generally used in day-to-day use cases. Mostly read committed is what primarily uses, and in rest of the cases you go with a repeatable read or serializable isolations. So I think so the read uncommitted, almost everything is possible. The dirty read is possible. Non-repeatable phantom and serialization anomaly can be possible. All of this. Read committed doesn't actually read the uncommitted data, so that's why the dirty read is not possible at all. But the other things are possible. So depending on the use case, where in any transaction you don't want a non-repeatable read to happen, right? So in that case, you should probably go with a repeatable read as a isolation level, and if you need a extremely absolute consistency, you just go with a serializable isolation. Yeah. So other things are the lock levels. So apart from the isolations and the kind of reads, right? So Postgres or any most of the relational databases support this locking at a table level or a row level. So these are the all lock levels that Postgres supports. So table level locks are basically locks acquired at a table, where you actually log the entire table and say that XYZ operations can't happen. And the same with row level lock as well. So row level lock, you basically lock a specific row, saying you can't do an update. Rest of the transactions can't do an update till so and so transaction releases the lock on a row. I will discuss about 1 and 2 in the subsequent slides. The page level locks are something more internal in nature. In most of the cases, we don't actually have to deal with this. So page level, so the database maintains the storage, stores this entire rows in a pages. So that's like another storage layer. This is similar to what you have in OS pages, right? In operating system, I think most of you guys heard about the pages, right? This is kind of similar to what the database also do. So the storage at a physical layer, right? So these are actually maintained at a pages, and so there are database internally acquires the page level logs to ensure it adheres to this whole the MVCC setup. Yeah. So the other one is deadlocks. So deadlocks are, I think, kind of where situation where multiple transactions kind of dependent on each other. So you kind of do a, let's say, update multiple updates in 2 transactions at the same time, right? So there is a possibility that one of the transactions is waiting for the other transaction to release a lock on a specific row, and vice versa. So in this case, both the transactions will be waiting indefinitely for the locks to be released, right? And apart from this, there is advisory locks. Advisory locks are something that generally custom locks that we can define from the application or within the database to ensure to kind of cater to any specific requirements, which doesn't actually happen with 1, 2, 3, or 1 and 2 basically. So these are like a custom application locks that you can actually create within the database. Okay. Yeah. So these are the lock modes at a table. The access share lock is kind of the default lock that gets acquired. So the moment we say lock, right, doesn't necessarily actually have to lock the row to kind of not allow rest of the transactions to do any operation. So by default, when you say lock, right, our expectation is that none of the rest of the transaction shouldn't be happening on that, right? So that is not actually the case. So logs are basically a way to kind of block operations or fail operations. So in this case, the access share log, right? So that is acquired by the select statements. Although it is acquired by each and every select statement on a table, it doesn't necessarily actually block anything except for maybe some alter statements and all. So it doesn't actually block rest of the select statements. It's like you can have 100 select access share logs on one single table at the same time. So because these are not blocking each other, so these are like 8 different logs that are supported in Postgres, and and each of them kind of block some of the different kinds of logs. And this is how Postgres kind of ensures what logs should be acquired by what operations, and how they are interrelated. This is kind of how Postgres maintains the sanity of the data. Right. So I think the access share lock is by selects, row share is by the select, but there is a select for update or select for share. I'm not sure if anyone here has used these, but the select for row update and the select for share kind of locks the actual rows and avoids you to do any updates. The select for update, for example, right? So it does you take this you basically query one of the account, let's say account for in a banking system, where you want to do a modification of the balance, for example. So in this case, you can actually do a select for update in one of the transactions, saying I'm selecting this account row basically to update further. So this with this the database understands, because it's important, you have to read the correct data, right? So in case account balance, let's say you have a operation where you have to deduct 1,000 rupees from one of the bank account, so in this case, you actually need to understand what the existing balance is, right? And then you deduct 1,000 if there is like some 10,000 rupees in the account. And if there is an operation to deduct 1,000, you have kind of update it back to 9,000, right? But in a scenario where after you read it as 10,000, there is some other transaction which basically there is another credit operation that came up. So in this case, the balance might be like 11,000 or something, because there is another 1,000 added. In your transaction, you basically read it as 1,000, you deducted 1,000, and you try to update it back as 9,000. But in reality, like there is 1,000 addition and 1,000 deduction, so you expect the balance to kind of remain the same, right? So you need to kind of tell the database that you are kind of reading this data because you want to update it back. So this ensures that this kind of gives a signal to the database that to not allow any updates during this time. So any further updates, right, they would be waiting for this update to complete. And so that is with the select for update. If you think about it, this is kind of a lower level than the insert, delete, and other operations. And the select for share is, I'll probably come to this in subsequent slides. Yeah, so required by insert delete. So this is by default, you don't want update to update blocking, right? So unless you are dealing with the same row, right? And so same with merge as well. The share update access lock is acquired by vacuum operation. So vacuuming is basically an operation where like you have a table, right? So where you continuously doing updates. So how Postgres handles updates is, so whenever you do an update on one of the row, right? So what Postgres does is it kind of marks that row as deleted or something, and so it creates a new row. So with the updated details. So basically your update is always update is always delete plus insert. Although the delete is a soft delete, it doesn't actually mark it as a delete. That's how Postgres handles. So there are no such thing as an in place update. So it's always insert plus delete plus insert, soft delete plus insert. So this way, like it kind of maintains does it much faster than other databases. So now the problem is if you have like high number of updates, right? So basically you end up in a table bloat scenario where you have like majority of the rows will be marked as deleted, and the number of rows that are actually live are very less compared to the number of rows that are deleted, right? So this is a scenario. This is what we call it as bloating. And so when a table is bloated, ideally, let's say if it's supposed to be 100 MB or something, and because of the updates that you keep doing and the concurrent updates that you keep doing, there's a possibility that the table might bloat to like 10 GB, 20 GB. So in this case, your query performance also becomes deteriorated, because your expectation is you would like to, because the data is scattered across 10 GB, right? What you should have in like 100 MB is now scattered across 10 GB. So obviously, whenever you're trying to read, it will be kind of taking up a lot of time. And so your index also kind of get bloated. It's not just the tables that get bloated. So in this case, like the vacuum, so Postgres generally provides this auto vacuum options, which will kind of ensure the tables are within the given size. So there are some parameters through which Postgres triggers this auto vacuum on the tables. And apart from this, there's also vacuum flow operation where you rewrite the entire table fresh with the live rows only. Yeah, so these are the this is what vacuum does. So shared update exclusive lock does is acquired by a vacuum operation. And if you think about it, this kind of has to block other insert updates, or may or may not actually have to block other insert updates, right? And yeah, so and the other thing is the shared lock. Shared lock is for the index creation. So whenever you're trying to do any index creation, your expectation is you don't want to have the data creation happening, right? So if you have a table on which you're creating an index in account, let's say I'm creating an index with account ID, which most likely is a primary key. But so if I'm creating an index on the account ID, right? So I would actually there could be new accounts that will be created on a continuous basis, right? So in this case, the account index has to be also keep getting updated. So when I'm creating an update, so this could be a never-ending process, correct? So that's why the shared lock kind of is acquired by an index. So here you have a scenario where you don't want any updates or inserts happening, right? So now the shared lock, since it is acquired by index, and there is a certain operations that you want to allow or disallow during index creation. So now the shared lock, that's based on which we need to figure out that shared lock should kind of have to block all these operations. So for example, it has to block all the insert, deletes, and select, right, and updates. So you would say that now shared lock should block all the access share and row exclusive locks. So that is how Postgres manages this internally, and ensures things don't interleave intervene between the operations. And similarly, there is a trigger operation. You can always set a trigger. For example, mostly people set it for the updated on row updated on statements, right? So you can set a trigger, or some of the alter statement like setting default and all, they acquire the share row exclusive lock. Exclusive lock is used for the view refresh. Views are basically there's something called materialized views, where like for example, I have the table of list of accounts in a table, right? Like I have an accounts table, and I always want to see how many accounts are active in my database, in my system. So now ideally I would do a count query on the database, right? Now the problem is I want to check this every 5 minutes or half an hour. In this case, you can actually have a view statement which says that you can do a count query and say that this is a view. So where anything that modifies, right, that in that case there will be a trigger to kind of update this view. And there are various things that you can do around that. View refresh is basically it auto performs the count operation separately in the background again and again. I think so. Like I think mostly people have these. People use it for the count operations. I think in Headout case, for example, you need to have want to have one of the counter in the landing page saying how many trips are booked in over last 1 year or something, right? So in these cases, you want to have views which will kind of reflect this data and auto refresh it periodically, right? So yeah, and apart from this, you have access exclusive lock, which is kind of the highest level of lock that can be acquired. So you have it for the alter statement, drop, truncate. Drop is basically like the delete table. Truncate is basically like a drop, just that you don't actually delete, but you don't actually drop the table, but you just delete the entire data. And reindex is where like some of the, as I mentioned, like the indexes can get bloated, right? So you would want to do a reindex, and if there are like majority of indexes updates on a table, you tend to do a reindex to ensure the index is more efficient, always efficient. So the vacuum fill rewrites a table completely into new. The cluster operation is basically, it kind of rearranges. You have a table where you always read data based on a time, right? So let's say you have a time series data, so but you don't actually want to have partitions, right? So in this case, you can actually say that, my table and all your queries are based on a time, right? So based on a time interval. So what you do is you kind of you create an index, obviously, to ensure the queries are faster. And the other thing you can always do is, like, you can always rewrite the table in such a way that aligns with the index that you highly use, so where every day could be one, like the data can be stored in a physical layer, in a sorted order of the timestamp. So that's what clustering does. Yeah. Okay. Yeah, this is a table of how each of this lock mode actually blocks or allows rest of the lock modes. So now you understood what each of the lock modes are acquired in, right? So by default, unless access exclusive is basically for your highest level, where for a table you oh, okay, sorry. For a table, you kind of acquire this, and now whenever doing a complete modification on a table where you say none of the operations should succeed, that's when you take the access share. Your access exclusive, and access share is basically your least strict lock mode, and that is acquired by most of the select statement. So mostly selects are completely independent; they don't actually interleave with each other. But this enables, like, now, since every operation has a lock mode, now you can clearly say that, like, indirectly with this lock mode, you can actually implement a solution where you can achieve what you want, saying, because each of these operations has a predefined notation, right? Where alter, when you're doing an alter, you don't expect, and adding a column, you shouldn't be allowing inserts into the table, right? Because the new column that's added, you don't know what value should it be for the entries that are being inserted. And also there is a consistency factor, right? Where like, what if half the rows are inserted with the column and half are not inserted without the column? So these kind of things are kind of handled with this whole lock mode blocking and other things. Okay, so yeah, I think we might be running short of time as well. So lock mode at row, this is, like, as I mentioned earlier, the select for, right? The select for update kind of is like you're doing a select, but at the same time you want to have a properties similar to when you're doing an update. So in this case, the select for is introduced. So it has like 4 different modes. Primarily, the simple selects are not actually blocked. So the four modes enable you to define how one select for can block the updates or deletes on a row, and also how it can block the rest of the select for statements. So this 4 kind of gives you 4 different combinations, and depending on your use case, you need to figure out which one would be good, ideal. So, right. Okay, yeah, I think I'll probably take another 5 minutes, and pose that we can, I hope we have enough time. Okay, yeah, PG logs. So managing logs, you need to have a visibility whenever you want to optimize or debug an issue. First thing is you need a visibility into what is happening. So Postgres provides PG logs as a table which gives you insights into what transactions are acquiring what logs, and there is also PG stat activity table which gives a visibility into what transactions are ongoing. So every transaction that you're running, right, there is a PID associated with that. With that PID, you can understand what logs are acquired with that, what locks are required against the transaction. So this enables, and there are different wait events, wait types, which will tell you exactly what each of these transactions are blocking. Let's say suddenly your database actually completely all the update statements are completely blocked, for example. So your database is the CPU is at 100%, or none of the transactions are going through, right? So in that case, when you're debugging, you see there are like a number of update or concurrent updates happening, or waiting, or concurrent updates are happening and you see them in the stat activity, right? You can actually see what these transactions are doing. If they're not actually doing, most likely they're waiting for some other transaction to happen. So, and let's say some user has run an alter statement, and that is taking forever, without a default statement on with a default statement on one of the row, right, one of the column. So they're trying to add a column with a default statement. So as part of this, all the existing entries, the default value has to be set, right? So this operation generally takes like hours. So in these hours, any updates that are happening most likely will be blocked, because this is an alter statement, right? So now you can actually see these statements in the pgstat activity. First thing is you look at the pgstat activity, understand what updates are happening, and then you can take up the transactions. You can see the wait event and understand which transaction all these transactions are blocked on, and you can understand what is actually running in the transaction. So this way you can narrow down to what is blocking the database from doing the regular operations. And logs are generally acquired not just on the tables, they're also acquired on the indexes. So this is one of the important points to keep in mind when you're adding indexes, right? Generally, if you have like a huge number of indexes on a table, so it will slow down your inserts one, and it will also slow down your updates and sometimes selects also. Yeah. And logs for partition table, if you have most of the time series data, you maintain the partitions, right? Most of the time series data you maintain partitions, and against the table you can have this different one of the against a parent table you'll have like child tables, which where the data you can have a weekly partition. So every week you can have one single table, and you can have a parent table which is like, let's say, accounts, and you can have account underscore some November 3rd as one day, and daily or monthly November as one table, October is another table, and so on. So when you query, right, so you generally logs are by default acquired over all the partition tables if you don't provide a partition clause. And apart from this, I think one of the things that most of the dev doesn't realize is, so when you're doing a transaction, right, your logs acquired for a transaction kind of remain with the transaction till the entire transaction commits or rollback. So if you have if you're doing a multiple selects, right, so if you're doing a select operation, your expectation, and you're doing a select star, get all the accounts that are created in last 1 hour, right? So now the thing is, so your expectation is the moment the select completes, the lock on the transaction is complete. The access shared lock on the transaction is on the accounts table is released, right? But it doesn't actually happen that way. So it maintains the database maintains links it. Once it assigns a lock to a transaction, it doesn't kind of keeps it till the end of the transaction. So this is very important how you order your code, because sometimes there is a ways where you can order it such a way your logs are quite minimized. The log usage is quite minimized. And yeah, and there is logs reside in memory. The pg logs is basically the table where Postgres maintains all the logs, and this is an in-memory table. And this has a direct relation to your scalability and speed. The more logs you use, the lesser scalable you become, and your speed also impacts because it's eating up your memory, right? So any other operations mostly based on transaction memory that's assigned, right? So you'll have like the more logs you acquire, the more memory pg logs eats, and lesser memory you have for your transactions to execute. So yeah, I think this is roughly a few things around how to manage logs. Okay, so I think yeah, we don't have much time, so I'll try to brush up. I have a few more things to cover. I think the application I've taken Hibernate as an example. So you have sessions. Mostly people would have used sessions. That is the interface through which you deal with the transactions in the database. So you have sessions are basically like a wrapper or a stub on the application side, and each session kind of when you execute the actual queries, right, it internally creates a transaction. So it gets a connection from a connection pool, and on top of the connection pool, your transactions get executed. So session is basically your side of the application side of the interface, and transactions are on the database, and the whole relation is maintained with the connections, right? So yeah. And it's important to kind of close the connection. So one of the things mainly most of the databases face problems with is the transaction doesn't get ended. So it's important to kind of ensure the sessions are closed in time. And so there are like mostly databases have this idle in transaction. If let's say one of the application opened a transaction and kind of died off, right? The application instance kind of goes off. So in that case, your transaction will be kind of in an uncommitted state forever. So generally, database as a sanity has a idle in transaction timeouts, like saying within 1 minute if the transaction doesn't do anything, so then it has to die down. it will be killed. So if these things are not there, then the database can go into a problematic state. Yeah, so the locking strategy, yeah, there are like optimistic locking and pessimistic locking. Optimistic locking primarily uses row version. Pessimistic locking is what we are kind of discussing so far. Optimistic locking is kind of out of the box way to achieve locking, but this is not foolproof. So it's like it works based on a row version thing. Every row has a version, and when you read, you kind of read the version as well. And when you update back, you kind of check that if you have the right version or not. If there is some other update happen, the version obviously changes, right? So this is another way to achieve locking. So this is a very clever actually way to do what you achieve what you want to achieve, but at the same time not have any not have the locking lock management overhead to the database. So I have some examples. Yeah, I think yeah, do we have more time or
Hey Sam. We actually have our next speaker in line. So yeah.
cool. I think in that case I'll just close it off here then. Yeah, that's all from my side. Any questions you have?
Thank you very much. We did have one question popped up, but I'm pretty sure you covered that in your presentation. So they dropped the question really early on in the piece, so I think we've got it all covered. But a big thank you for joining us today and for dialing in and sharing your wisdom with us. It's an absolute pleasure to have you. So thank you once again from all of us as we are dialed in from around the world.
Okay, thanks, Kenan. Yeah, thanks everyone for having me. Thank you.
You did, yeah. All right. Just a quick reminder that you can continue to drop in your questions as we go through our presentations today and hear from our different speakers. And if you have time, we'll definitely make sure that we cover as many of those questions as possible. I also want to remind you to make sure that you like and subscribe our YouTube channel for sure. Keep up to date with everything that's happening. I would now like to introduce to you Johnny Berger. Johnny actually has been based out of Switzerland for the last few years. Johnny, can you speak Schweizerdeutsch yet?
Hey everyone, yes indeed. Ich kann Schweizerdeutsch reden. Das ist sogar meine Muttersprache. Maybe there's
nice.
one person that understood this.
I myself lived in Switzerland myself, so I understood a little bit of what was going on there for sure. But yeah, well, before we pass across to you, Johnny, I just want to take a chance to just give people a little background. Those people who don't know Johnny, he is the founder of Remotion and also the chief hacker there too. He's a very enthusiastic runner, and sometimes he just takes trains to go to other cities so he can run there. Which is actually pretty nice to do. I can tell you that. He loves a good hackathon, so I'm sure he's pretty excited to be with us today. In fact, he recently participated and even won Europe's largest hackathon very recently. And if you're interested to keep up with Johnny, he has his own YouTube channel where you can find him. It's at Johnny Berger. So I'm sure he'll be able to give you some more information in his presentation today. So once again, thank you very much, Johnny. Pleasure to have you here and take it away.
You definitely know your stuff. Yeah, that's right. For those who don't know me, I'm Johnny Berger and I'm the creator of Remotion, a way to create videos programmatically in React. And we will show you how to actually do it in a session. And for this, I should be joined by Sid as well. So let's just wait for him to appear. Hey, Sid, good to see you.
Hey, man, here I am. Thank you so much for joining. Let us quickly share our screen. Meanwhile, can you walk us through what Remotion is, what it allows people to do? Because when we first came up with this topic, a lot of the first responders were like, how would you write videos with React, right? That's just not an idea that occurs to very many people. So how did you end up at this problem statement, and what caused you to want to try and make something like this?
Yeah, for sure. The idea seems a bit abstract, doesn't it? So we can make nice websites and have many graphic effects in it, gradients, blurs, videos. The web is actually quite a capable graphics platform. And the idea of Remotion is that we turn these web technology, the things that we can make with web technologies, into videos. And Remotion is a framework for that. You essentially write a website, animate it using our helpers, and it allows you to export your animation as a real MP4 video.
Awesome. In that case, let's jump right in. Folks should be able to see my screen now. I am at the homepage of Remotion, remotion.dev. In case anyone wants to poke around the landing page, see a little bit of the code on how that works, you can head over here. Meanwhile, though, let's zoom into the project that me and Johnny actually wanted to show you. So very recently, in fact, practically yesterday, we expanded, Johnny and team expanded Remotion to sort of include this transitions library. And they have created what I think is one of the most dynamic and lively 30-second launch videos that I've seen in quite a while. So I'm going to drop a link on this chat. Somebody in the moderators can help us do that. Check out this video. But to give you an idea of how this video is made using code, I'm actually going to jump into the project file. So here we are in VS Code. Johnny, what are we looking at? What is this? And how do we start to make sense of this? Where are we at? I'm going to punch in slightly so folks can see. And we are at the index file, the root of the project.
What we are looking at is at a project which contains a bunch of TypeScript files, React files. This is how the video that you've just briefly seen is created. And in this index.ts file, we just use it as an entry point for our list of compositions. And a composition is essentially just a video that we want to render. So maybe you can click on the Remotion root variable and we can see the list of our videos. So
awesome. But before we move forward, I look at this project and this very suspiciously looks like any other vanilla React project that I could have possibly seen, right? It literally looks like something that we just ran create React app with. There's a public folder, which I'm guessing houses all of the assets. There's a source folder where I've written all of my React components. And in fact, they all just have the TSX file extension. How does a video get formed? I guess that's what we're going to look at, right?
Yes. This is really a framework that is for the people who are better programmers than animators. People that come from React will feel more comfortable in this. And I myself come from this, and this is why it also looks very similar. And we also have like integrations with Next.js where you can like make a video right in Next.js. And
awesome.
What we are now looking at is the main composition. This is like the master video, which contains all the scenes. But in this project, I've also listed out a lot of smaller elements so that I could work on them at once.
Right.
Create many small units and then compose them. That's what React is really strong at.
Correct. I see this composition right here, and you seem to have a number of these compositions that essentially look like React components to me. And they each have a duration in frames, they each have an FPS, and they each have a width and a height. So this to me seems like we're describing the properties of a video. Could you explain to us what a composition is and what it means in the context of Remotion?
Yeah, so a composition is a way to define a render output, to define that how a video should be rendered. And each video needs to have some basic metadata, like it needs to have a duration, a frame rate, and of course width and height to define our canvas that we can draw on. And this is what we do here. It includes the metadata, but it also includes the ability to add a React component, which then of course is responsible for determining how the video is going to look like.
I see. Should we jump into one of these React components and see how stuff works under the hood?
Yeah, let's do it.
Any recommendations as to which one?
So we can take a look at the main component. That is just the full video that I ended up publishing.
Awesome. This one you mean?
Yeah, and it seems like I had some unnecessary nesting in it, so maybe jump straight to the main sequence.
All right,
actually, I had to remove the music from the GitHub repository.
I see.
That's why it's now just referring to another component. And in here, you can see our new Remotion transitions package in action. So we essentially have a lot of sequences that come after another and that have a transition in between them.
I see. The word sequence is also something that's very Remotion specific in nature, right? What is a sequence, and how do we make sense of this within Remotion?
So a sequence is like a scene in a video, like an individual animation that could also be its own composition. But with a sequence, you can place it in another composition and then assign it a start time and a duration, so that you can write your React component you can write your React component first and only later decide at which point in the video this sequence is going to appear. That makes it easier, so that if you decide to add another scene in the video later, so that you don't have to adjust all your components to now appear 10 seconds later with a sequence, you can like time shift the components. I think it is better visible if you also start the project and we can look at the timeline to give people an idea.
Awesome. All right. So I'm going to jump into package.json and I'm going to see that we have a start script and a build script. I'm just going to run yarn start to start off the project. And let's move over to Edge actually. There we go. It's on localhost 3000. Okay. Here we are looking at what I assume is some sort of or Remotion's dev server equivalent, right? This is where I can see or preview my work while I'm developing the project.
Can you make your browser a bit bigger maybe? Seems like it's perfect. Yeah, now we can see it really well.
Awesome. So I'm looking at this. This looks very familiar as somebody who's done some video work in the past. There seems to be a timeline. I have some list of compositions on the left, and I believe I can see a preview in the middle, right?
Yeah, totally. So the first frame is blank, but now as you scrub through the timeline, you can see
there it is.
a lot of things going on. Actually, this is a pretty fast-paced video where like every 5 frames something new is happening. And the clue of this video is that it is entirely made with the Remotion transitions package to show it off. Of course, also using a lot of nested transitions. We kind of have like scenes that fill out the whole screen, which transition between words or colors, but then there's also transitions between those scenes.
I see. So if I understand this correctly, if I borrow a few elements from the video editing sort of universe, we use or we essentially write what are React components to describe the look of our video. we use sequences to determine at what point in the video should these things appear or disappear. And then we choreograph these sequences in what we call a composition. And the composition then is responsible for telling the compiler or sort of the renderer how to make this into a video file. Is that understanding correct?
Yeah, this is correct. So how I approach this video editing is that I create just a small animation that in itself is not that complex, and you can see a few of the units that I've been working on in the
Right.
left sidebar, and feel free to also click through them, and you can see this is just this 4 balls animation itself, and there it starts at time 0.
Right.
And then once I create the main composition, then of course it only appears later in the video. And so I use a lot of sequences to, in this case, it's a sequence in a series, which will automatically put it one after another. And each one of the items that you see on the left are compositions. That's essentially just
I see.
a way to make them previewable in the studio
Got
and
it.
allow them to be rendered.
Awesome. So what it looks like is that we've essentially taken the construct of clips that video editors would sort of cobble together, and we've just instead said, hey, what if instead of clips, we just write React components? And the abstraction that React provides lends itself very well for these small sequences and compositions to be able to be very modular, and then we can stack them together and combine them in interesting ways to achieve what looks like a fairly orchestrated sequence of clips right here.
Pretty much, yeah. Sequences are just clips, and what you're seeing is like actual web content. So this is all based on CSS essentially. And one thing that blows people's mind is that now you could like right click on one of these boxes and inspect the element, and to
wow. So
and
I have
people realize this
essentially
is a website.
created a video out of just divs.
Exactly.
That's awesome. That's really cool. So we're writing HTML, right? Which the browser knows how to parse, and there is CSS that helps it determine how to style it. How does writing this HTML actually ultimately allow it to be a .mp4 file, which is a video? What happens in between for this to happen?
Yeah, so imagine just screenshotting a React component that you could imagine, right? So
yeah,
but animating this React component over time, this is where Remotion helps you a lot. So we expose a hook called use current frame, and this gives you as a number the current time in the video. So in the Remotion Studio, you can see it even at the bottom left, what the current time is. And your task as an Remotion animator is essentially just to, based on this time, render a React component. It can be almost anything. And therefore, the content needs to change over time.
I get it. So what I'm hearing is that we've written this particular clip, the NA1, using SVG, but theoretically, anything that you could render on the web, whether it is WebGL, whether it is maps via Mapbox, some sort of fancy shaders that we've injected into a canvas, you could leverage all of these things and still be able to use them in Remotion to create videos out of.
That's exactly right. So we can make map animations. The WebGL with WebGL do 3D stuff with 3JS. That's I think some people are doing. This is something that is of course harder to do, to integrate 3JS, and on our side we also have to think about how do we then render this in the cloud, which is also a feature
Right.
of React, and it's not easy to buy an instance in the cloud with a GPU and then attach it to this Chrome browser. So just recently we figured that out, but yeah, like then achieving this stuff is some of the most rewarding work about Remotion.
Yeah, I can understand. I get it. So, what is like the you invented Remotion, right? You thought of a use case where you could leverage web technologies, create a static site, animate this static site over a period of time, and then stitch those frames together into a video. What have been some interesting ways where people have sort of used this technology and created things out of that you had not previously imagined?
So I will also call out Headout later, because you did something really cool with it. But I think the most common use case of Remotion nowadays is that companies use it to build a web video editor where
Right.
people can drag in certain elements, maybe record some video, maybe infuse some AI generated content, add captions to it, transcriptions, overlays, effects, and see them in real time in the browser before then exporting it as a video. So that is I would say, one of the most interesting use cases of Remotion, where then actual companies come and
Right.
build something big with it. But it could be for anything. It could be for dynamic social media videos, anything that has some repeating content, anything that you could create a template for and then render a series of videos with some dynamic data. Remotion could be useful for. And I know that Headout used it at their conference to create some of these motion graphics on these really big screens,
Yeah.
which was really cool to see it being used in real life as well. Or
I
like
love how you
see it
said
on screens with people walking around it. That's super cool.
I love how you said dynamic repeated content, because that's one of our favorite use cases here at Headout. We sell a lot of tickets to real life experiences, right? A lot of people go skydiving, go to museums, and they tend to click pictures of their experiences and they tend to share it with us. And one of the really interesting use cases of how actually I ended up discovering Remotion is that I wanted a way to capture all of these media that our users were essentially sharing with us and then combine them in interesting ways and offer something back to them. Whether it was like hey, this is your experience in review, check out how the photos that you've shared with us look in this sort of highlight reel, for example. And we ended up doing that for a lot of our users, some of which we broadcasted in our conferences. But the ability to fetch dynamic data from anywhere, because Remotion is essentially just a website, right? So you can you can make a fetch request and get any sort of data that you want, and then populate your video with whatever you get. So that sort of use case was very interesting to us, and before that, it didn't even look like an option that we were quite happy with, right? You could do this in Premiere, but there's a lot of hacky plugins that you sort of have to write over. So that use case was very exciting. And that was almost 2 years ago. Since then, there are so many cool things in Remotion that have happened. Google Fonts became natively available. You can now render Lottie and Rive animations inside of Remotion itself. And this was my dream feature, the ability to just transition from one part of your sequence to another was just one of the things that I've been eyeing for so long. And yesterday it just looking at this video put a really big smile on my face, and I can't wait to play around with this a lot more. How did you work on this transitions piece? What sort of effort did it take to enable this?
First of all, I'm really glad to hear that you were waiting for this feature. I think so were many people, and really happy to know that you will be using it. This one was actually, it took a lot of time just like experimenting and thinking about how the API should look like. And I remember that I was working on this transitions package already like last year in the summer in a train, like with a mask. So it must have been in development for like about 1.5 years now.
Right.
And of course, like making a simple transition is good, but then I wanted something where you could build any type of transition and also nest it. What about like adding audio effects to a transition? Like so many things that I wanted to have in there. And I think the part which made me actually put it out was that I realized the transition is essentially like a presentation where
Right.
it decides the visual effect. Is it a slide? Is it a vibe? Is it a fade? Essentially like the appearance of a transition. And then there's also the timing. How long is it? Is it like a spring animation or linear or a Bezier curve? Like that. So at one point I realized, okay, these are the two things that make a transition. And now with the release of the package, we've made it so that we have a few timing presets, a few visual presets, but you can also add your own presentations to it. And with this, and after I think almost 2 years of thinking about it, I think we finally found the right API to allow full flexibility.
That's awesome. And looking at Remotion sort of like growth over the last couple of years, I've noticed that because this is a very technically challenging space, right? You have to sort of figure out a number of use cases and then invent entirely new paradigms of thinking and frames of reference that you wouldn't have as a benchmark otherwise. A lot of uncharted territory works happens here. And while doing this work, I've noticed that there are a lot of interesting side quests that you've had to chase on the way, right? One of my favorite ones that both you and I have done some work on is the version of FFmpeg that Remotion uses. And I imagine that took a really, really, really long time, and it was a really long-winded journey of how do you take something that's been powering a gigantic universe of multimedia programming over the years and then adapt it to work for something like Remotion? How did that come about, and what sort of work are we talking about here?
Yeah, indeed. So FFmpeg, for those who don't know, is like a multimedia tool that is being used at every company which does video. So like even YouTube, probably this live stream that we are doing here right now somehow involves FFmpeg. And
I recall even Chromium-based browsers shipping with FFmpeg. So if you're watching this on Edge or Google Chrome or Arc, you are already using some parts of FFmpeg under the hood.
Absolutely, every Chrome has FFmpeg in it. It is huge, and there are like two ways to use FFmpeg. So there's the CLI, where you can give it a command and it will execute it. And how we would use it in Remotion is to just like execute this command line command to do something. But then there's
Right.
also a lower level C API that you are supposed to program like it says in C. And this allows you to do much more stuff, but you have to write a C program. And for me as a JavaScript programmer, this is scary. And we wanted this flexibility, but the CLI would not give it to us in all cases. And this year I kicked off a Rust project which would bind to FFmpeg's C APIs. Like, I did not do it all myself. Used a lot. There's a library, Rust FFmpeg, that is out there that gives you the bindings for it. But combined that with some custom work from our own part, we now have still access to the CLI, but can interface with it through Rust, which is a really fast language, and that allowed us to improve the rendering performance quite a bit.
Yeah, I get it. I've actually run some benchmarks on the CLI version of FFmpeg versus the vanilla like C API itself. One of the use cases that was particularly interesting to me is capturing frame buffers and then encoding them to video. While you can do it with the CLI itself, you sort of have to sort of encode your buffers into a string, send that via your standard input to your CLI, and only then FFmpeg, the command line, can read it. And you sort of avoid this round trip altogether if you just make calls to the C API directly. So I'm sure there's, especially with how wide the use case for Remotion is becoming, I'm sure there's a lot of enabling that will happen thanks to your work on FFmpeg. Any other such similar side quests that you have to sort of pursue while solving what Remotion is solving?
Oh yeah, plenty. So I put out this idea of like capturing a lot of screenshots and then turning this into a video. And of course, at the beginning, this was very shitty, and we had to fill in so many gaps to make it usable. Like
Right.
for example, the transitions package, but then also like cloud rendering is a big part, and we are building a distributed video render on Lambda. Then I built a small 3D SVG 3D engine in SVG.
Wait, sorry, I want to double click on that. You build 3D in SVG.
Yeah, so essentially you have like an SVG path, and then you try to extrude it, also render the back face and the faces on the side with a lot of trigonometry, which
that explains
ended
why I
up
couldn't
using,
think of
but
it.
I don't really understand. This project is now on ice because we have like problems with anti-aliasing, and we have problems with the C index. So if you have like multiple elements, we cannot figure out which element should be in front. And yeah, that makes me a bit sad, but I ventured into 3D SVG as well. And the next side quest that we are doing is we are doing a project for GitHub, where at the end of the year, every GitHub user will get their personalized video. So I've already done it last year, and this year I'm working with like actual animators, and they still use After Effects, and now we're trying to figure out how to best take the work that they did and put it into Remotion. And this is going to be some of the most complicated Remotion graphics so far, and we're like for a space team, so we have like rockets shooting GitHub issues to close them, and that's a pretty big side quest that I'm now
I would
doing.
argue that it's way past a side project now. I think it was a side project last year when you just zoomed through the whole thing, But I think at this point, I'm really looking forward to seeing my own GitHub version of the video that you make for me. Love to see it. So
Cool.
I have one more question in that case. We've sort of been using Remotion for 2 years, right? And you mentioned a lot of things like being in deep with SVG, a lot of web technologies, some Rust, some low-level code. What is your background like? Where do you come from? What gave you the exposure to such a wide array of sort of technologies? What were you doing before Remotion?
I was making React Native apps actually for a few years, my own apps, and then I also worked at an agency which made React Native apps for customers, and that got me familiar with React. And the work that like Christoph Magiera with Reanimated and William Candillion with his tutorials did on the React Native side of like making performant animations in React inspired me to try my own and make like animations based on gestures. And yeah, then I ended up recreating or like creating Remotion based off that experience.
I see. But like it sounds to me like there's not been a lot of like exposure to low level programming early on, and then you just sort of choose to attack something like FFmpeg head first after you ran into a problem that you felt like you could solve. And so from the native universe to the web universe to now a lot of low level programming, I think you sort of like completed the whole arc there. You have been running Remotion as a team for quite a while now, right? How big is your team? How has that journey worked out?
Yeah, I'm very lucky to, since a year, do it full time, only work on Remotion. It allows me to also go into a lot of side quests. And we are now a team of 3, me and one other developer. And we have one guy managing the whole operation.
I see. And I'm sure like at this point, there'll be a lot of questions in the chat, a lot of people pinging me on Discord. How do we learn more about Remotion? How do we learn more about the project? What is the best place, the absolute best, where people can treat as like a one-stop shop and learn all that they want to learn about Remotion?
Okay, if I can mention one platform, then I would suggest the Remotion Discord. Remotion dev/Discord. It's a community with, I think, nowadays almost 3,000 members building with Remotion, and I'm also in there pretty much every day, all day.
Yep, and so am I. Not as often as Johnny, of course. My job is to sort of break things with Remotion, and then I go running to Johnny on, hey, I broke this. How do I fix it? And Johnny is very kind, and he often offers to help. We've made a bunch of cool projects with Remotion this way, and I have had a blast working with Remotion. I'm very excited with the new developments. I'm very excited to see where the project is headed. And for any of you all interested in video, and for those of you who've been meaning to exercise your creative muscles, build something that's really fun and engaging to look at, give Remotion a try. Feel free to build hacks on top of it. There are the Remotion community is actually one of the most friendliest places that enable new and first time contributors to open source. So if you've been meaning to get into open source, the Remotion repository is a very solid starting point. It was mine. One of the first most meaningful contributions I've done is in and around Remotion, and I'm very happy about how the team and the community has shaped up. So go join the Discord. It's right here. And you'll notice that there's a lot of people sharing inspiration, a lot of new discussions happening, and it's a very fun place. But meanwhile, Johnny, thank you so much for joining us. Thank you so much for taking out the time. We are poles apart on the face of the planet. What time is it there for you?
It is lunchtime right now.
I see. Um, well, it's been a very fun conversation. Thank you so much for joining us. Are there any questions in the chat that you'd like to address? Let me uh, quickly jump up here and check.
Yes, and what chime in as well is make sure that people remember to ask their questions. We do have a few minutes right now, so if you haven't popped it into the thread just yet, make sure you drop your questions in now while we still have Johnny and Sid on the call for a few more minutes. Sid, I just want to say, like, it sounds like you're moonlighting in QA, going in there and breaking things and just going to try to get them fixed. We do have a question here. Excellent. Vikram's chimed in. What are some performance level problems that have come up while building Remotion? And secondary question, what are the interesting automations? Like, what are all the interesting automations that you have done? So 2 questions there.
Yeah, a big topic. The biggest one that comes to my mind is that if you wanted to include a video into your video, we first have to read that video, and for that we used Fmpeg to like extract a certain frame from a video. And one big performance problem that we had is that through the CLI, we like if you want to extract a frame, the video first needs to be opened, and since videos have keyframes in them, you first have to extract a lot of different images before you get to this image. And with the CLI, you could only extract 1 frame at a time, which meant you open the video, you go through the video, find the frame, close the video, and then you have to reopen it again. And that is one thing that we now have fixed after 2 years using some Rust code. Another thing that I will tackle at some point is actually with audio. So on Lambda, we currently have this problem that if you stitch together some AAC audio, it's like a codec, like MP3, you get some popping and crackling noise, and that means we have to re-encode the whole uncompressed audio into AAC on a single Lambda function. You cannot parallelize this work. So that, for long videos, slows down the render. And maybe at some point I'll just try to write something like a new audio encoding program that works in parallel.
Well, you mentioned the Lambda, right? I feel like the Lambda cloud-based rendering itself was quite a clever solution to just parallelizing the whole thing and spawning multiple Lambdas to render a video. That itself would have resulted in quite a meaningful jump in the rendering times. How was how was the render done before Lambda? I actually can't think that back.
So you can render a video on one machine. To speed it up a bit, you can open multiple Chrome tabs to screenshot the frames, and that way leverage multi-threading. But with Lambda, you can take it to the next level. You can, if you have a 1 hour long video, you could spawn up, let's say, 60 Lambda functions, which each render 1 minute of video. And then they'll get passed to a main Lambda function, which then stitches it together. And in this case, like I mentioned, we have this problem where we need to re-encode the whole audio, which I hope to solve in the future. So Lambda is like an optimization on top of that, but you could also render like an hour-long video on a single machine.
Yeah, I see. You also very recently launched the alpha version of running Remotion renders on Google Cloud, right? What makes that approach different from Lambda?
So the main and obvious thing is, of course, that it runs on Google. This is mainly just like a preference some people have. Hey, we are a Google shop. We want things to run on our Google shop because we have on our Google account because we have everything there, but also to add a bit of variety in our approaches. This is not a distributed render. This is like an integration
I
where
see.
you will just render everything on one instance for now, although we could imagine adding this distributed rendering to Google Cloud as well.
I see.
Great.
Is there a
Did you have another question there, Sid?
No. I think me and Johnny have a like a I like if you let me go on, I will probably take up Johnny's entire day and keep asking him questions because we both like have very similar interests and like the tinkering spirit to jump into this multimedia encoder or why does this one work and this one doesn't. So I think one of the most interesting use cases of Remotion that I'm potentially looking forward to and soon or at least trying to enable in the future is right now the focus of Remotion as like a product and a platform is cloud based, right? We want to be able to allow you to render as many videos as you like at scale in the cloud. But I also think there's a lot of potential here to be able to leverage your native processing power to be able to just render videos on device. And I've put together a few prototypes here and there of bypassing the cloud, so to speak, and trying to render Remotion videos natively. I think that's where I've managed to break a lot of stuff. But it's one of the pet peeves of mine that I just wish I could bake Remotion into a native app and not have to make round trips from the cloud every time. But we'll get there. We'll get there soon.
Yeah,
good progress.
sometime in the future, for sure. Well, we do have like 1 minute left. Like just in closing, Joe, I want to say thank you. But do you have one last bit of like wisdom that you want to share, like a summary, just something that our viewers can take home as this is the golden nugget from Johnny today.
The golden nugget. Wow, that's it's hard for me to say. But what I can say is, like thanks a lot for allowing me to also like feature it on Hackout. I hope a lot of cool hacks come out of it. It's like a really cool like stream and stuff that you have going on here, and I'm happy to chat about any things like Sid has brought up with like the alternative ways of rendering. I am now like a full-time working on this and happy to explore anything programmatic video. Okay, I guess this was not any wisdom.
But it sounds like you're always willing to chat about it.
Things I wanted to say.
Now, maybe I can suggest that, like, if anyone has would like to reach out to Johnny, like, like as I said at the start there, he does have his own YouTube channel, Johnny Berger, and so you can see some of his videos. I know that you've also listed there like links to your other social media profiles, so if you want to reach out to you, I'm sure they can like talk all day with you about Remotion. And so thank you once again, Johnny, and thank you also, Sid, for helping in the facilitation here.
No worries. Happy to help.
Thanks a lot for having me.
Thank you, Johnny. Thanks, Kai. I'll see both of you soon. Yeah. Peace.
Take care. Well, everyone, we are down to the final stretch here, and I hope that you all be enjoying the speakers and taking on a lot of new content and useful tips from our different speakers. We have one speaker left. I want to introduce to you Nishant Arora, who is the co-founder and CTO at Olvi. Olvi helps businesses discover insights from their support tickets, their sales calls, and communities, and to ship the highest impact product or the highest impact thing. And before Olvi, he was part of the early engineering team at Atlan. So there's a little bit of background there. But what is quite interesting about Nishant is that he didn't start necessarily in this field. Back at school, he started blogging, and blogging led him into marketing. which led him into building websites, which led him to building front-end apps and back-end and big data. And so he knows a little bit about a lot of things, the jack of all trades in the tech world. I imagine that you'd be quite a challenge in a Trivial Pursuit or another general knowledge quiz night. But yeah, just before I pass it, looks like we might have lost the shot for a second. So just while he gets his camera back on going and the microphone working, Nishan also says he loves to spend his free time in rabbit holes on the internet, and they change more often than he likes to admit. But Nishan, can you hear us there at the moment? We're still struggling to get your camera back on.
He's just joining back in. Let's just wait.
Not a problem. As I mentioned to everyone earlier, just want to remind you that feel free to put your questions in the thread as the session goes. We'll touch on them at the end of Nishan's session if we have time. He may even be able to address it in the presentation too. And a reminder to also please like and subscribe our YouTube channel to keep up with all of our updates. You there, Nishant?
Yeah. Hi. Sorry, had some issues there.
That's all right. No problem. Well, thank you again for joining us, and we look forward to hearing what you have to share. You are our very last speaker, so you've got our undivided attention.
Awesome. Yeah, sure. Would love to start. So just let me share my screen. 1 second. Okay, awesome. Let's start. Just a second. Let me see if everything is fine. Yep, we're all good. Awesome. So before I start, this talk, the title for this talk may not have anything to do with the content I'm going to talk about, right? I've given it just a fancy title and that's all there is. This may just be, me dumping my thoughts on how I think about being a generalist, or maybe it may just end up being a very big exercise in confirmation bias, right? But yeah, this is going to be me talking about how to think about being a generalist. Some of you may have this dilemma. I had this. I was going through the same thing very early on, right? Like when I just joined the workforce, doing some internships. I was like, people around me know a lot. I don't know a lot about any particular thing, right? I was very much focused into the breadth of things. So just to help you also think about this, or just share my thoughts on how I think about this entire dilemma, right? But before we get into this, the first thing that we should start with is, who are you listening to, right? Who am I? Right? So this is me. I am Nishant. I'm one of the co-founders of Allwe, where we are building a tool to help companies listen to user feedback across multiple places. Where traditionally companies run surveys, we say that your users are already sharing feedback on your support tools, marketing tools, with your sales team, and all of these other places. We bring that all in one place and give our customers reports, analytics, and insights on top of that feedback. Before Allwe, I was part of the early engineering team at Atlin, where I got the chance to basically help build the product from day one, saw that entire startup journey from 0 to 1. As the host mentioned, I basically got my start when I discovered blogging when I was in school. Then sort of got into online marketing, made some amount of pocket money there. Then realized that I really enjoyed building websites than writing. Right, I really enjoyed designing my blog. I like designing my blog more than I liked writing it. Right, so that's where I moved on to web design, learned HTML, CSS, learned how to build those pages, and post that I realized, HTML, CSS is not going to help me build interactive apps. So I moved on to front end. Learned React, learned front end frameworks, got there. Then my front end apps needed APIs, so I learned how to build back end, how I learned to do APIs. Then I was working at a data company. So it was natural for me to also get into the big data stack. Got there, right? And today at Allwe, we are running into some of those infra scaling challenges. So now I've turned into an infra person, trying to learn database internals, trying to see how do I optimize all these response times, latencies, and work on getting into how does container orchestration work? How do I do zero downtime deployments? Trying to figure all those things out. I can be found with this handle at NSHNT Aurora on most places. And this talk is just my opinions, from some maybe borrowed, from my experiences, right? To help you think about this too. So let's start. Yeah. So first thing that I want to ask you is like, who are generalist engineers, right? Have you ever seen a job post about a generalist engineer? No, right? Nobody's ever seen this. So, yeah, this is going to be the shortest talk in history. Okay, thanks. Bye, folks. Let's stop screen sharing. Okay, no, I was just kidding. Let's actually start. That joke doesn't work on this, right? It works best when I can see people's faces. Anyway, so who are generalist engineers? Like traditionally in these textbooks, you would have found this famous diagram. Like you see, there are specialists, there are T-shaped people, there are pie-shaped people, there are M-shaped people. You know, people call them all these different sort of shapes. But why you don't see people hiring for generalist engineers is mainly because they're usually hired as full stack engineers or founding engineers or anything engineer at a startup. Right? Any engineer at a startup just ends up becoming a generalist in some form. But on the top level, generalists are mainly differentiated on their ability to ship complete solutions to problems fast. Right? So these are two very key words here. Like that's the complete and fast. These are the two things. Then specialists are people who can go hard, solve hard problems, go deep into them, and solve things that nobody else can. But talking about this diagram, like this today looks like in the real world, in my opinion, this looks more like a spider web. Like you have one core speciality, but you have multiple things that come from that, and all of those are interconnected. It forms this complicated web. These traditional diagrams, pi, t, m, only works in textbooks. Nothing like this exists in the real world. I have never seen someone like that. Right? And if you notice the two things I mentioned there, right? Like generalists can ship complete solutions fast, and specialists can solve hard problems by going deep. Both of these things are not mutually exclusive, right? You can build things fast, and you should also be able to solve, hard expertise needed problems. And the image there is just for me to make sure what mutually exclusive means. That's all. But yeah, having said that, people can do multiple things, right? It's not necessary for you to be fit into a particular bucket, right? You don't have to go into, I'm a generalist, I'm a specialist. But, that's also a fact that all of us have finite time. And, it's difficult to build an expertise in multiple things. So yeah, that's where generalists happen. But one thing that you should focus on is what's your differentiation. Like with generalists, the differentiation becomes, oh, they can build anything from end to end very fast. With specialists, the differentiation becomes, oh, this guy can solve problems that nobody else can. Right? They're the best at this field. And that's the core thing that I think you should remember with this. Like when you go in, the first question that you should answer is, what am I bringing to the table? What's my differentiation in this entire piece? And before we talk more about being a generalist, like first thing that I want to, clarify firsthand is specialization is what pushes things forward. To build, to work on the bleeding edge, to build things nobody has ever built, to go to solve problems that, very hard. You need to dedicate a lot of time. You need to specialize in something. You need to spend years on a particular problem to actually get to that expert level. And it's these specialists that push things forward. Right? It's these specialists, somebody built out Kubernetes, AWS, ECS, or other deployment systems like Heroku to make it easy for generalists like me to deploy or ship their apps without worrying about implementation details a lot. Right? And yeah, I was trying to look for an image that showed an advanced society and focus, how specialization pushes. I just added a society and Ford focus. Anyway, so having said that, like with the focus on specialization and how specialization pushes things forward, that's the ideal way, right? Like that's how things should be in an ideal world, in my opinion. Right? Everybody should focus on one thing, become great at that, become the best at it, and yeah, you're all set, right? You make more money, you're way more happier, maybe. But yeah, I don't know a lot about that, but that's how I think ideally it should happen, right? But the problem there is that ideally only works in physics, and that only in textbooks, right? Doesn't work in the real world. Real world, you will come across multiple problems. Probably one thing that you specialized in, few years down the line, completely goes obsolete. Nobody cares. Your specialization goes for a toss. Then you have to move to something else, right? So it's always a good idea to spread yourself out a little, hedge your bets a little. So yeah, then why are generalists needed? Right? Generalists are created and are needed in resource constrained environments where you have not a lot of time, you don't have a lot of people, you probably don't have a lot of money, and you need somebody who can do the work of 5 different people, right? He may not be doing great at all of these 5 things, but he can check every item and get that thing to production, right? And at these companies, and these resource constrained environments are startups, right? And at these places, you need people who can go from, okay, I'll pick this up to here you go. And talking about generalists, the best example for a generalist is Batman, right? The only reason Batman had to become a generalist was because he couldn't convince people to come to his cave for an interview, right? Like he couldn't hire people, even if he had the money, but he didn't have anything else. Ended up becoming a generalist. But next thing is, how do I become a generalist? Like, what does becoming a generalist look like? And some cases it's curiosity, it's people taking their own initiative, people just trying random things out, people taking their own initiatives there. And majority of the cases it just ends up happening. Like you see this comic on the right hand side, and that's exactly how I got into this. So while I was at Atlin, I experimented with this tool called Apache Atlas, right? And there what happened was, I didn't know anything about big data, I didn't know about anything, I just got into it, and few months down the line I was onboarding everybody else in the team to come in and maintain it, right? Like I became the residential expert for those few months on that particular technology. And that's how you end up becoming a generalist, right? You end up picking new problems, you end up trying to solve them, and even if you don't solve them, even if you don't do a very good job, you end up learning a lot more about that, right? And so talking about these stories, like let's move to some real life examples on how I have seen the kind of issues, the kind of things that I have run into, and how I have used that to basically improve my skills there, or basically how I ended up becoming a generalist. Like when I started, I wanted to build my own app, and the best thing I found was Ruby on Rails. By this time, I had only built some UIs, some websites, and that's all. And that's where I sort of pushed myself, learned Ruby on Rails. Then the company I worked at, Atlin, didn't have a product design team in the early days. Right? Now they have a lot of designers, but at that point, the front end engineers were the designers. So that's where I learned. I was a front end engineer there, so I learned the basics of product design. How do you think about this? Patterns, design systems. Learned my basics there. Then I wanted to deploy my side projects I was on. Learned how to host apps. Learned how to set up CI/CD pipelines. Right? I learned how to set up monitoring systems. Then at work, I didn't like the time backend took to fix the issues that I reported with the APIs. I was like, okay, I'll do it myself, and basically got into the backend code base. Learned schema design at that point. Learned how to build these APIs, and that's where I got into the backend side of things. Slowly at Atlin, I moved from being a front end engineer to a backend engineer. This is how that sort of journey happened. Then I've already told you the story how I got into a little about data engineering. Then now we're at the state where we've gotten a lot new customers come in after our launch. And that scale, the amount of feedback that we're processing every day is sort of increasing, right? And we need to scale the systems very hard. So we are slowly hitting a point where we'll need a specialist. But until we get that, I am the one who's sort of getting into and building my specialization into these things. So that's how my journey has been like. And this is some real life examples on, how things happen and you end up becoming a generalist. So I want to talk about a few things that have helped me basically get up to speed on these multiple things, or that maybe will help you, right? And the first thing I'm going to talk about is learning fast. So as a generalist, your core strength, what you bring to the table is your diverse knowledge, right? You can do front end, you can do back end, you can write content, you can do marketing, you can do all of these things, right? And this diverse knowledge is the strength. And the only limiting factor there is how fast you learn or how much you retain. First thing is how fast you learn. So the faster you learn something, the faster you can build and the faster you can ship something, right? So how do you learn fast, right? Like I don't know, it may be completely different for you, right? You may first have to discover how you learn. You may have to build your own playbook, right? But I'll just share my tips that have worked for me, right? Like when it comes to learning fast, first thing is build your own playbook to get up to speed on anything. Like build this checklist that, whenever I'm picking up a new technology or whenever I'm picking something new, this is how I approach this. If it's technical, I start with reading the docs. If I do this, I run it, I'm local. Second thing, if it's non-technical, I talk to somebody who's already done it, get their top level view, then basically deep dive into the topics they have suggested. Or, maybe you have a blog or any other resource, right? Second thing is, if you want to learn fast, what speeds this entire process up is if you get your fundamentals right. Because essentially everything that you're talking about in computer science is ones and zeros on a very basic level, right? At the hardware level, this is just binary. So everything is the same. You're building front end, you're building back end, you're building whatever you are, right? And if you get those fundamentals right, if you understand those basic classes that you're probably taught in your college, I would say second year, third year. Yeah. After that, nothing very generalistic or very basic comes in. But what you need to do is you need to get these fundamentals right. And the best thing about this is these fundamentals are transferable, right? If you know how websites work, how browsers load web pages, that will maybe help you build better APIs, right? Because you can prioritize, you can optimize based on that. You can, as a backend engineer, you can work with your front end team to optimize these things. Third thing that works best for me is read a lot of things you don't understand anything about. Right? My favorite way to do that is, every morning I come in, I open Hacker News, I find 10 blogs about random things that I have no experience in. Somebody's talking about embedded systems. Somebody's talking about some other problem that is too hard for me to get in at this point. But it always helps me to basically go ahead and read those things, even if I don't understand them, just so that I know that they exist. Even if I get, let's say, 1%, 5% of that, retain that info, or pick up one particular thing, that is something that could prove to be useful. Plus, if tomorrow I get into a problem that is similar, I have something in my mind. I know where to start. I don't start with zero, right? I have something, I know these are the things that exist. These are the things that I should look at. And this just sort of speeds your entire learning process up if you know where to start. Because that's the biggest friction, right? That's the first question everybody asks whenever they want to learn something new is how do I start? Another thing that's helped me very well in learning fast is just run everything on your local. Like, don't cloud environments, everything, they're all good, they're all fancy, they help you a lot. Reading the docs, everything's good. Watching video tutorials, perfect. They're a good source. But for me, nothing beats running that system on my local. If you're learning a new technology, like few months back, I was experimenting with AutoGPT. Tried a few of these agent tools on the web, anything. But eventually, when I ran that code base on my local system, got into the code base, understood how that thing actually worked internally, that helped out a lot on getting up to speed. So, you can't learn fast running on the surface level, on watching videos, on just reading, right? You have to be able to run everything on your local, try everything out, play around with the code base, break 100 things, spend 3 hours solving Python dependency issues, but that's all okay, right? Eventually, you'll end up spending a lot of time initially, but on a longer timeline, you'll end up learning way faster. Then, next thing that I want to share with you folks is become a specialist. I know how this sounds. Like I'm talking about generalists, I'm, telling you all good things about what it's like being a generalist, everything. But the one tip I want to share with you is become a specialist. For me, I spent majority of my time doing front end, right? So that became my expertise, and that helped me a lot to basically move to other functions, right? If you have basics right in one place, you have the fundamentals right in one place, that helps out a lot. But what are the other things that, the one core thing that helps with being a specialist is that, how good, how fast, or how correct your solution is depends on how well you understand the problem, right? It's a function of how good your understanding is about something. And it's the specialists that have that, that expertise. And what you need to do is spend a lot of time. So even if you're a generalist, even if you're anything, fall into any of these buckets, don't fall into any of these buckets. There will be points where you will have to go deep into any problem, at some point and solve a very, complicated thing that will take you a lot of time, that maybe you're not being that you're not a lot comfortable in. And another thing with this is that it's easier to draw parallels to learn, right? If you understand one system, if you understand one piece of technology, it's very easy to understand a different piece of tech. Like if you've got into the React code base, if you understand how React's reactivity system works, fundamentally the problem is same, right? Like every front-end framework you see is trying to solve the same problem. How do I make easy to build these UIs? How do I make it fast? The core problems are the same, right? Everybody's just taken different solutions. So if you understand one solution in depth, if you become an expert in one solution, it makes it easy for you to draw parallels and bump up your understanding to a different framework or to a different piece of technology. It works very less when it comes to different functions. Like marketing and engineering, it's not that critical. Maybe doesn't work as well. But in one particular function, talking about different parallels, like going to front end, back end, big data, infra, all of these things, if you become an expert in one thing, it's very easy to draw parallels and move to other other lines of this. Next thing I want to share with you folks is, go around helping people. So this is something that helped me out a lot. I learned a lot about what I know from the office cafeteria, right? Because during lunchtime, you had multiple people come in, you were talking to everybody, you were trying to see, somebody was telling you about the new thing they were doing, new initiative, new campaign that they were running, sales team was sharing about what their sales process looks like, right? And this is something that helps out a lot, because first thing is, every person that you meet is a walking crash course in their function. You meet a marketing guy, they will tell you, you meet a marketing guy who's writing website copy, right? They will tell you one quick playbook, right? They'll tell you what do they look at, what do they focus on. And that's just enough for you, right? Like what you need is the starting point. So that gives you a good starting point to start. Like let's say the marketing guy says, oh, first thing you want to get right is get the above the fold headline. They get that main tagline, hone that. Then move on to talk about the value propositions or whatever their playbook is, right? Once you know how that thing works or how that person thinks about that problem, it makes it very easy for you to switch, to start and go deep into each of those points. They may give you a very bird's eye view of things, but that's the starting point, right? After that, it's your curiosity, it's your ability to learn fast that sort of helps you out there. And one thing that works very well with this is just help these other teams out build these random things. Like help your sales team out build automations on LinkedIn or the CRMs or whatever. Help the marketing team write content about the new features that they're shipping. So just helping out these different functions, working with them, just makes you improves the breadth or improves the diversity of that knowledge. And that knowledge diversity is only comes from people diversity. This is actually a good line. Yeah. Anyway. But another thing that I want to share with you folks is don't marry a tech stack. Right? I have interviewed folks who come in, I'm a React engineer. I want to work in Vue. I'm like, cool, bro. React is going to get obsolete in the next 10 years. Right? Nobody knew of React 10 years ago. And yeah, that's the thing. Focus on the fundamentals and don't get married to a particular technology. Don't get married to, oh, I am just this. I'm going to focus on just this. Technology becomes obsolete faster than you can keep up with it. Right? Like ask all the COBOL programmers who built those banking systems. They ended up making a lot of money during COVID because of the shortage, right? But that's the thing. Nobody is using COBOL today in production, except those banks, which are also in the process of migrating. So somebody who had a COBOL specialization would be out of a job in some years. So fundamentals will remain the same, right? You get good at the basics, you learn how to learn fast, and you can pick up any piece of technology and get up to speed on that. Right? And the last thing that I want to talk about, the last thing that you should focus on, the last thing to know is everything is a trade-off, right? Like anybody who says, there are no trade-offs everything in engineering is a trade-off, right? Like if you want something fast, you will have to compromise a little on accuracy maybe. If you want something very accurate, it may be a little slow, right? And we are all making these trade-offs every day in every function we write or every application we build. And I also recently learned that there's a fancy name for this coming from the machine learning world. They call this the explore-exploit trade-off. Started from the machine learning world, ended up becoming a general principle in the decision-making process. But yeah, this is what the topic that we're talking about, generalist versus specialist, is about. Like it's the explore and exploit trade-off. I'm at one point, do I explore what else is out there or do I focus there and exploit everything that I have? Right? So that is something that we have to understand, that going either way or both of these paths have different pros and cons. So the trade-off that you're making with going with a generalist or a specialist, few top points from the top of my head are, first let's talk about what do you lose. First thing that you lose is like, as a generalist, if you focus on breadth, that means you may not end up being the best in the world in one particular thing. Because the fact is, as much as we'd like to believe, being the best at the world in one thing needs you to spend years and years, needs to you to spend that time on that one particular thing, honing that, so that you can be the best. Because there will always be other people who are going to be way better at you at that thing, because they've spent more time and they've done more things in that particular thing. So that is something that as a generalist you have to be very as a generalist you have to accept that you may not end up being the best in one thing in the world. Next thing is, a lot of places what will happen is, because of this, that you're not the best in the world, it may end up being difficult for you to get into deep tech research oriented roles, right? Those options may be limited, because if a company at that level is hiring for an engineer who can solve this complicated uh, you know any problem. I'm not going to think of any example, but that what will happen is, they'll have 10 people, they'll pick up the person who can solve that particular problem. It's a big company, they'll hire the person who's best at that job, and this is where your options will get limited as a generalist. So that is why my one tip: become a specialist in one thing, so that if that situation happens, you have that one thing to fall back on. Third thing you lose out on is money, right? Like, specialists are always paid more, right? The best example that people give out is, the sales of Swiss knives are way less than the sales of actual kitchen knives that you use. Swiss knife does multiple things. Kitchen knife does one thing great, right? And it has been seen, like, there has been records, I've seen my friends, right? People who are specialists in one thing, they end up making a lot more money. If that is something that you're optimizing for, do not focus on being a generalist. Right? Become specialist at one thing, and you will find 10 people, 100 people in that problem will pay you a lot of money for that. But with this, what do you gain? The first thing that you gain is imposter syndrome. You can't do anything about it. It comes free with this entire thing. If you think of yourself a generalist, you have an imposter syndrome in some form. Right? And that is something that I'm still learning how to get rid of, or how to solve. But yeah, I had to, because this is something you gain, so I added it in. But next thing is that the breadth that you gain, right, with this experience, with trying out these multiple things, is it just opens up your entire options to anything that you find interesting. If you started with one particular technology, that's it, right? You in the future, you learn, if you start out with one thing, you learn more technologies, and then what happens is, slowly you can go into anything, right? You can choose to specialize into anything in the future, and that just opens your options up. Third thing I see is, it's very fun, right? Like, if you are someone who likes exploring, who likes trying new things, one thing you could also get is a ADHD diagnosis with this. But if you enjoy having fun exploring new things, if you enjoy having fun trying these things out, you automatically end up becoming a generalist, right? And another advantage that you get is, you just have a way better understanding of things around you, right? If you're an engineer, you understand how business functions, what are their priorities, how marketing works, right? What are their KPIs, how sales team works, and that is something that that helps you become better at your job. That helps you understand, okay, what is the total company around, what are our focuses, and you get a better understanding of the market. Why are you getting paid, right? Where is your salary coming from? Or understanding that entire big picture becomes a very good advantage to actually move up the ladder. Another thing is, the best part about this is, it gives you skills and the experience to build your own idea. If you are someone who wants to start up on your own, right, the first thing that you'll run into is, you won't be able to hire enough engineers. So you should be someone who can build your entire product, or someone who can actually get more people to build your entire product. But that's the secondary option. Primary option is, you get to build your own thing. And to do that, you have to have that level of breadth to actually build solutions. Post that, you can hire specialists who come in, solve every problem that you can't solve. But you need a generalist to get started there. And that is one advantage that you have over others. Now, that's all the main points I had. So this could have been a tweet. These are the top things, how I summarize this. Like, first thing that we should know is, like, this is a very subjective decision. Like, I see people in the chat, right? Generalists are a myth, specialists are a myth. It's a very subjective decision. Nobody knows the right way. It's on you what works best for you. Next thing is, where will you thrive depends on the type or a stage of company you are in. Like generalists are a very good fit for startups, but at a larger company, a generalist may not be able to do a very good job, because there you have one team or one person responsible for one particular thing. They don't have to move around different functions or help go around and work on different things. And that's the one thing. Generalists thrive very much at startups. Specialists are valued more at larger companies where you need those people to come in. Third thing is, like, even if you're a generalist, even if you're a specialist, if you're a specialist, you're a specialist. But if you're a generalist, start with a specialization. If you have that one specialization that you can always fall back on, that you can always draw parallels on, or where you can build the foundation of your knowledge, that just makes you a better generalist. That just makes it easier for you to move to other technologies or other functions, or move to the next new thing that you're exploring. Next, another thing that helps you is just learn fast. Pick up any topic and see how fast you can go from zero to production. I think that is something that will help you gauge how fast you are at a particular thing. Like, pick up an idea, start building something new, see how fast you can get to a working model, and see how you can reduce that entire time. Build your own playbook. Next thing is, the one thing that you need, another thing that you need is curiosity and a willingness to help. If you're not curious, if you end up doing things just because you have to or you've been asked to, you won't even do a good job at being a generalist. So curiosity is something that you have to have. So it's like, if you want to know more about something, if you have that curiosity, you will obviously deep dive, you will learn more, you will eventually get a way better understanding of this, and that just makes you better at that another thing that you're picking up. So curiosity is the core idea of being a generalist. Next, willingness to help. Like, as I mentioned, diversity, I'll repeat that line that I discovered again. Diversity of knowledge comes from diversity of people here, right? So if you are willing to help others, that just helps improve your knowledge of different functions of these different people. People are a walking crash course of their own functions. Next thing is, being a good generalist is also a specialization in itself, right? It limits your options a little. You are perfect for startups, and in larger companies, you may end up getting into leadership roles, management roles, or people management side of things, just because of the breadth you have. But being someone who can build anything you throw at them, being someone who's great at being good at things, that is also a specialization in itself, right? So let's keep that in mind for the generalists there. This is just to keep me happy. Second thing, the last point is, it's never a bad idea to learn something new. Even if you're a specialist, even if you're a generalist, just try out the next new thing. What's the worst that can happen? You will fail at it. You'll give it a few hours. You'll realize, oh, this is not going to work out. I wasted my time. Let's go back to the drawing board. Let's get somebody else to solve this problem. But you'll end up learning a little more. And that's the core thing you need, right? The breadth of knowledge. The depth automatically comes in if you have curiosity. So yeah, this is the dump of my thoughts. This is everything that I wanted to share. And yeah, I think this was way shorter than I expected. But yeah, that's all.
And like, look at the big difference between like being a generalist and a specialist in the industry. I'm going to ask again, like, to see if anyone has any questions. I have seen that the thread has been exploding with with comments, but I don't think there's been any questions in there, to be quite honest. But while we wait for people to chime in, if they have any questions to ask you, I just want to say, like, Nishant, is there anything that, I mean, I guess you call yourself a generalist, so you found your place in the world. I guess it's definitely a personal choice. Like, as you said at the end, like, what are you wanting out of your role? What do you want out of your career? Like, what kind of successes do you want to have? But I guess, is there something that you want to share in summary? Like, just to close, put it all together, or maybe just so that everyone has something to walk away from your session today.
Yeah, like, you say I found my place in the world. I'm like, no, bro, I haven't. I am still learning. I still go through this dilemma. Early on, it's like a lot of these discussions happened. I'm like, oh, do I want to do this or no? Like, do I want to get deep into this one particular thing, become an expert there, do that? I went through that entire dilemma, and what I wanted to do was share my thoughts on how I have come to a conclusion here, because I'm like, if I just keep on thinking about this, I won't have any time to actually do something. So
Yeah.
I just wanted to share everything that my opinions here. But one thing that I want people to take away from is, this is not something that I could tell you what's the right way, or anybody in the world could. Right? Like, you have to figure out where do you enjoy, where do you have fun, and if you have fun at these right places. Sorry, I'm getting some background. If you have fun at solving new problems, it depends a lot on the type of person you are. If you are someone who likes going deep into a particular topic, becoming an expert, you know being a specialist is perfect for you. Someone like me who likes trying new things, who likes exploring new things, being a generalist is very good for you. But they are not mutually exclusive. That's the one thing I would say everybody should take away. Like,
Yeah, absolutely.
focus on being a specialist, build one specialization, but stay open to other functions. Stay open to being a generalist, because you don't know, tomorrow your entire specialization will be automated by AI.
Exactly. No, I think it's very good. Like, I want to chime in as well and repeat here what you said. It's like no one's saying that you're lucky what you want to do and do it for the rest of your life right now. You'll probably find that if you're looking to be a generalist, like you probably experienced yourself at some point in your journey of being a generalist and learning, you stumble across something and go, oh wait, this is really interesting. I want to dive deep. I want to specialize in this because I didn't know this existed, but now I want to know everything about it. So it's probably going to be a little bit more flux throughout your career, right? Moments where you want to learn as much as possible, moments where you go, this is where I want to deep dive and become the expert on this topic.
Yeah,
we do have a question here. Oh, sorry, go for it.
Yeah, if you're very early in your career, don't think about being a specialist. Just start being a generalist. If you explore these different things, you will find out what you actually love having fun at. Right? Like, I got into front end because I wanted to intern at a company. They saw my profile. They just assigned me front end engineering. Right? I didn't think I wanted to be a front end. I wanted to build front end. I wanted to build back end. I was just assigned that particular thing. I learned about it, got into back end, realized I liked that more. Right? So early on, don't worry, just do anything that that is thrown at you, and go deeper into multiple things. You eventually find something that you love.
So I could definitely agree with that. Usually when you're doing something, the right thing pops up.
Yeah.
Exactly. There's a question here from Sid. He said, well, what would you say to a generalist who likes everything but wants to find their specialization in something?
Yeah, I would say, if you want to find your specialization in something, it depends. Just being a generalist who likes everything is also a good specialization for you, right? And I don't think you should worry about finding your specialization, because that will end up happening. What you need to focus on is exploring things. If you still have to think about this, if you still have to compare different options, that is not something that you've become a specialist in. That is not something you want to become a specialist in. If you're still comparing, right, these things eventually end up becoming naturally interesting to you. And if you are the kind of person who's automatically a generalist, who likes that breadth, who likes to explore new things, I have never found something. I would have also liked to be a specialist in something. I think of myself as a specialist in front end, but I am not. You put up any very experienced front end engineer, they'll probably beat that out of me. I am not that expert. So if you're like someone like that, you probably may never end up finding your one specialization. So yeah, I'm sorry if that's not the answer you were looking for, Sid, but those are my thoughts.
No, that's fair enough. I think it doesn't matter whether you're specializing or whether you're generalizing. What stays the same for both is the hunger to learn.
Yeah.
Whether that's in a specialized area or just in general, it's the hunger to learn that's going to help you grow and be successful.
Yeah, 100%.
Great. Does anyone else have any questions before we finish up? We got a couple of minutes left, but we'll probably have a couple of topics to discuss before we close. So I think what we'll do then, Nishant, is say once again a very big thank you, and it's great to have you as part of our speaker sessions today. And we thank you once again from all of us who have been participating today.
Yeah, no, thank you so much. Thank you for giving me the chance to talk about a very abstract topic, which also gave me a chance to structure my thoughts as well. So yeah, it was a very
absolutely. Thank you for having. Thank you for being part of it. Thank you, Nishan.
Thank you. Bye.
Well, that's it. That's the end of our speaker sessions for Hackout 2023. And I want to say once again, a big thank you to all of our speakers, to Vikram, to Niha, to Shab, to Johnny Berger and Sid as well, and also to Nishant at the end there. It was great to have you as part of our speaker sessions for Hackout this year. And great topics, nice variety of topics that we could all pull some information, some take-home pay for sure. I also want to do a big shout out to all, once again, to all of the campuses who are helping us out here. We're hosting people on site who've been joining today. Once again, to IIT Allahabad, to Delhi Technical University, to IIT Kharagpur, and to IIT Madras. Big hello, big shout out. Thank you for being a part of the call today. Thank you also to everyone who's just been joining from their own home, through YouTube or Twitter. It's been great to have you as part of the session. We want to also remind you that we are pretty much minutes away from Hackathon starting. And so it's at 6 p.m. IST. And so make sure that you're ready and raring to go for Hackathon to kick off. Thank you also to everyone behind the scenes, to our hosts, to making sure that the tech works today. And thank you all for all of you for being here. It's been an absolute pleasure. Have fun at the Hackout. We look forward to seeing what you come up with.